Welcome everybody. Folks probably aren't here yet. Hello to any early birds. Go on mute for just a minute. Hey Rascal, welcome. Go on mute for just a minute. Hey, welcome all too swift. I'm afraid Rascal 2 beat you out by just just about a minute or so, but good try there. How's your weekend going? I hope everyone is having a good Sunday so far. Anybody doing anything fun this weekend? I know for those of us who are here in the U.S., we have our Independence Day weekend this weekend. So sometimes there's fireworks or cookouts or things like that. Hi, Chris. Oh, thanks, all too swift. Dakota, yeah, coding, that's fun too. Absolutely. Actually, a pretty nice day where I live. Not a lot of wind. Yeah, I mean, my weekend's going well so far. I'm lucky enough to have tomorrow off, the July 4th. I'm lucky enough to have that off. So I get an extra weekend day this weekend. Oh, Snarfin, that's rad. You're finishing up your text to speech mini app for your son. That's so cool. Hi, Nate Dev. Welcome. Good to have you here. How's my audio? Do I sound good? Sound quality okay? Excelente. All right. Eclectic, thank you. Eclectic, sorry, I said that wrong. Awesome, great. Glad I sound good. Let's go ahead and dive right into it today. Hey, Ann Graham, welcome. Captions. Thanks, Rascal. All right, 2 seconds. I'm going to turn captions on, and I'm going to switch over to my screen here. All right, welcome in, everybody. Like I said earlier, I hope everybody's having a good weekend. Give me 2 seconds to turn captions on for folks. Before the real bot reminds me. I know Rascal's my human my human stream bot, but the real bot would have reminded me in a few minutes. But I appreciate the reminder from Rascal there a little bit ahead of time. That's much appreciated. All right, captions should be going now, so thank you. Um, Snarfin, that's so cool what you're doing with that app for your son. Yeah, that is so neat. Hey, doesn't matter if it's perfect right out of the gate, right? That's what minimum viable product is for, and then after that you iterate. Welcome in, folks. Welcome in. Yeah, so today we're doing something a little different. So folks have been asking me pretty much ever since I first mentioned that I work with SQL. Folks have been asking me for some kind of a stream about SQL, right? And so originally I was planning to do it, but I was going to wait until after we'd kind of touched on it in class, because I like to stay sort of in line with the lesson plan for the course. But what with class being on hiatus for a little while, I've encountered quite a few folks who have said they have encountered SQL as a requirement on their like on their job postings that they're trying to apply for. They see SQL listed and they feel uncomfortable because they haven't touched it before. They don't know, they don't really know anything about it. And so what I want to do is to kind of help ease that anxiety by giving you a bit of a crash course in SQL. This is going to be like pretty high level. We're going to practice, but we are going to get our hands dirty. We're going to practice. We're going to do some examples and sort of work on these concepts by doing, which is my favorite way to learn things. If somebody sits me down in front of a PowerPoint, that's all well and good, but the only way I'm really going to absorb it is by actually doing it. So that's what we're going to do today. And yeah, this is sooner than I was intending to talk about SQL, so we'll see how this goes, but I think it'll be fine. Yeah, we're gonna basically give you the crash course in the basics today. So I hope we have a good time and we learn some new stuff. And yeah, as always, feel free to ask questions as you have them. And SQL it's a really long-lived and sort of mini splendored language. So there's a lot of different concepts and approaches and things we could do, but we're really just trying to focus on the basics today. So there may be times when somebody says, well, why don't we do it this way, or asks about it, and I might just say that's valid, but we're not going to do it that way. We're going to stick with the basics. So we're just going to try to keep things very SQL 101 today. But of course, feel free to ask questions as you have them. Hey, I'm Sazzy. Well, this is actually not something that we've covered in class yet. This is a little bit of a extracurricular, but like as I said, I want to make sure that people who encounter SQL, on job postings don't feel intimidated and can at least, handle a question or two if it comes up in an interview. So that's really the main goal here, is to make sure that you are prepared as possible for these types of questions should they occur in your inevitable job interview. Because I know y'all are going to get interviews undoubtedly, and I want you to be as successful as possible. Mavi, you studied for this class. My goodness. Okay. Yeah, Cassava. So we actually are going to be working with a lovely sandbox environment today that will allow us to screw up if we, whether intentionally or unintentionally, we're going to be allowed to screw up, and we're going to be allowed to restore our data back to its pristine state with a click of a button. So we don't have to worry too much about that. That's why I wanted to give you this sandbox environment, because it's very forgiving. So, which is a good thing. Hey, Hertz, that's a start. Yes, you know what it stands for? It's called SQL. Yes, great start. Absolutely. Okay, well, it looks like we got a fair number of folks trickling in. I'm sure my audience is not going to be quite as large as normal today, just because of the holiday weekend. So we're going to go ahead and get started. Some more folks might join us as we go, but the cool thing about today's course is that it's not really in line with class, so you can come back and watch the VOD whenever you. Yeah, we're not going to be using VS Code at all today. We're going to be using just a browser-based sandbox environment to do our coding. So, and I have slides. So, yeah. I'm hoping it's not going to be a terribly dry PowerPoint. I'm going to be asking you questions, and hopefully we'll have a little bit of fun. But all right, here we go. So this is an intro to SQL. But before we get into SQL itself, I want to ask you all, what is a database? What is a database? What do we use databases for? Yeah, right. It's a place to store things. It's a place to store data that we can, access and retrieve things from when we need it. Otherwise, it just kind of stays in there, right? And we can modify it inside of the database. We can, delete it, we can add new data, we can do all these sorts of operations on it inside of the database itself. So we don't have to store all of our data inside of, let's say, our server code, right? We can have it stored inside of this external database and retrieve from it whenever we need it. Yeah. It's a collection of organized data. Exactly right. Yeah. Oh, Loda, hi from Guatemala. Wow, welcome. Good to have you here. Yeah, it's remote storage. And in the case of the analogy that I like to use, it's like a delivery person, right? They could start out by carrying all of their packages in their arms, which is how we kind of started when we were writing our server code, right? We kind of just stored our data inside of our server.js. And that worked when we only had a few things. But when your code starts getting to be, 300 lines, just because you're trying to code a crap ton of like arrays and objects straight in your server.js, that gets to be a little much. And so just like a delivery person, eventually when they get popular enough, when they get enough packages, they're going to want to store them in a truck, leave that truck in place, and only go into the truck when they need to get something out or put something in, right? So the truck is separate from themselves. And so that's essentially the purpose of databases. Yeah. All right. All your database are belong to us. Exactly. Yeah. Oh, and by the way, too, I have a link to these slides as well that I posted up earlier in chat. I will post it again. It should be just a view only link. Let me know if it's not, but it should just be view only within Google Docs. So there you go. Here's the link to the slides again. Take a look at that, and you can follow along just like we do with Leon on his slides. All right. So the next thing is, all right, so NoSQL versus relational databases. So we know what a database is in general, but so far what we've done in class is we've worked with what's called like a NoSQL database. MongoDB is a NoSQL database, and what NoSQL stands for exactly can vary depending on who you talk to, but essentially it's different than the types of databases that you generally use SQL to work with. So this top image here should look pretty familiar to you, right? This looks like some of the things we've been doing in MongoDB, right? You have essentially, a JSON kind of an object, right? With various properties. You have an ID, you have, these various keys here, and they all have values assigned to them. And this is all contained within a single object. Yeah, MongoDB is document-based, exactly. And that's kind of what we've been working with so far. If you're following along with 100 Devs, that's what we've been working with so far, is these sort of document-based databases. Yeah. And so NoSQL stores individual document objects containing key and value pairs and contain a variety of data types. It's pretty, like, you can be pretty wild with it as far as the types of data that you include. However, the types of data that SQL is generally built to work with are what's called relational databases. And this relational databases store individual tables containing rows and columns of data. And these tables may be joined together to retrieve these combinations of components. And so this bottom, I do enjoy eating waffles, yeah. And so this bottom image here is literally the same information as what's up top, except it's in relational database form. So let's take a look at this. So the first thing that we see here is a row in a table, and it has some information about Leslie Yep. And it has a user ID, which matches there. It has the first name, it has the last name, the cell phone, and the city. However, it doesn't list out the hobbies. The hobbies themselves are included in a separate table, and each hobby has its own ID. It's matched with the user ID for Leslie, and each hobby is listed separately. Now, you might say, all right, fine, like why did they do it that way? Like, why wouldn't they just have one single table with a row for Leslie and a list of all her hobbies, like in a separate, column over here? Or maybe why wouldn't they have like 3 rows, right, with the same data on all 3 of these for these first 4 fields, and then 1 line for each hobby? Well, that's not really considered best practice when you're working with relational databases because, um, yeah, yeah, that's right. Because other people may have the same hobbies, and so you would have redundant data, right? If you're um, listing the same hobbies multiple times, and so it's much more space efficient to just be able to join to a hobby dedicated hobby table. Um, and yeah, there's several reasons for this. And so, but let's think about what if I wanted to let's say that I had 3 rows for Leslie, one for each of Leslie's hobbies. So one row for scrapbooking, whoops, sorry. One row for eating waffles and one row for working. And each row had all of the same information, just a different hobby each time. What if I wanted to update Leslie's cell phone number? I would have to update 3 rows just to make sure that her cell phone number was updated properly in all 3. And so that could introduce a lot of room for error, right? If you accidentally somehow only updated one of those 3 rows, then you have data that's in conflict. And so this practice of kind of ensuring that our data is in number one in the appropriate table and number two as sort of streamlined as possible is called normalization. And there's a lot that goes into normalization. We're not going to focus on that. Just know that normalization is basically the act of kind of separating data out into the appropriate tables, making sure that it's non-redundant, and making sure that it prevents anomalies when you're trying to do updates and inserts and changes. Yeah. Hey, Purple, welcome. Yes, you are just in time. We're just getting into the introduction now. So, yes. Oh my gosh! Metal and coffee. Wow, thank you so much for the raid. Welcome, everybody. Wow. Thank you. What were y'all working on today? Today, we are learning about SQL. So if you want to stick around and learn about SQL and get a little practice in on using SQL, that's what we are planning to do today. Yes, welcome, raiders, indeed. Thank you so much. Good to see you all. Hello. Yeah, I am Sassy. The IEs that I work with at UPS use SQL to predict package volume and flows. Yeah, actually, we're going to probably do something very similar to that today in a real example. You're going to get to practice doing that, writing a query that's going to help you predict shipper volume. Yeah, or not predict it, but query shipper volume. Yeah. Oh, you're working on a next.js app. That's so rad. Yeah. So normally I do, for those of you who are new here today, I'm Mayan Wolf, and normally I do sort of like MERN stack type projects and lessons, but today we're doing something a little bit different, and we're learning about SQL, which is the structured query language, very common database language that you see on a lot of job postings. And so that's what we are going to learn about today, just to kind of give you a crash course so that when you see it on a job posting, you can confidently answer, yes, I can write you a SQL query. So that's what we're doing today. Yeah, Linda, in your interview, normal, and we were just talking about normalization. So just basically just glossing over it very lightly, that normalization, yeah, helps you kind of separate out data into the appropriate tables, and it also helps you prevent anomalies or issues when you're trying to then change that data later. Yeah, and Linda says, in my interview, he also mentioned that normalization prevents unnecessary null entries that you end up with when you don't normalize data. Yeah, just the anomalies that can happen. And so don't stress too much about the details of normalization. Just know that that's kind of the definition, because you might get asked about that in an interview, as Linda did. Yeah. Yeah, exclamation point Leon in chat. Yeah, there you go. If you want to learn more about the course that I'm currently enrolled in, which is called 100 Devs. However, I am a SQL developer in my day job. So yeah, that's what we're learning about today. All right, so let's go on. So why SQL? All right, so why do we care about SQL, right? That's not what we're learning. For those of you in 100 Devs, we are learning the MERN stack, which involves MongoDB as its backend, right? Literally a NoSQL database as the backend. So why should we care about SQL at all? Well, SQL is basically the original database language. It was first started back in the 70s, I believe 1974. So it's been around for Yeah, almost 50 years now. Somebody said 48, and I think that sounds right. Been around for 48 years. I'm gonna hydrate real quick. So it got started with disco, hence the image here, and it is still around today and still widely used today. I mean, it's what I've built my career on so far. Um, and SQL is designed for accessing, modifying, and extracting information from relational databases, like we talked about there, from tables, from those databases that are made up of tables with rows and columns, and those are by far still the most common database type today. NoSQL databases are definitely gaining ground, but relational databases are still going to be what you find in most places. So good to know about, good to understand. And you might say, okay, fine, sure, SQL's great and all, but there's so many tools out there that allow me to make changes to databases without coding at all, like GUI type tools. And I can build apps without knowing any SQL. I can, use that. I can use these tools that sort of abstract it, make it object oriented, paint a layer over top of it that makes it easier. Well, there are times when a GUI is not going to get you what you need, and it's not going to be able to be flexible enough or written appropriately to really get you the info that you need and to make it as efficient as possible. For example, before I was a SQL developer, I worked as a data analyst, and we used a GUI-based tool to retrieve data from a database, which is great. You drag it in fields, you drop them in there, you do your filters, everything's GUI. It's just clicky, clicky. But there were times when I knew that I could write a SQL query that would be like 4 lines long, could get me the data that I needed in like 10 seconds, whereas I would have to, where I would have to spend like 20 minutes doing it in the GUI interface. It just wasn't always the best way. And so being able to write SQL can let you just get data in a snap. Yeah, and I'm not really exaggerating there. I mean, there were times when I would just be like, dragging my fields in and trying to apply my filters and getting things to sort correctly using this clickable interface, and I'm just like, man, 10 seconds. I could just code this out and it would work so much faster. But, you know, you work with what you got. But in this case, yeah, SQL is a great way to just cut through all the noise and get directly to the data that you need. Amadeus, you followed because you can relate to this stream. Oh, that's awesome. Good pun, too. Hey, HJ, I'm glad you're enjoying the subtitles. Yes, we have captions if you need them. You can turn them on or off using the toolbar, should appear on the right side of your screen. Yeah, Edward. Yeah, and relational databases tend to show up a lot in like commerce, um, uh, when there's transactions involved. As far as like logistics or production or sales, you will generally have a relational database on the back end of it. Yeah. Well, Hazel, that's kind of what I was saying as far as ORMS, which tend to kind of abstract that like SQL code into something that's more object oriented. And I'm not saying they're bad. They're a great way to help people interact with databases. But I do still think learning SQL is a valuable skill. Dev Puddle, is there a lot of coding involved with being a data analyst? Data analyst is a very broad term. Um, it depends. I'm just gonna say that. Sometimes you don't need any. If you're using GUI interfaces and you're doing a lot of things in Excel, that kind of thing. Some data analysts, that's what they do is they build really complex Excel tools, or use stuff like an access database or things like that. Other data analysts are interfacing with databases directly in one way or another. So yeah, it just depends on your employer. Okay, here's a great example. Yeah, Kasava says, I love SQL. My job didn't use it, and I showed it to our CEO and ran a coworker's report that she took 3 days to do and got it done in 30 seconds. Yeah, absolutely. Yeah. Yeah, Sleepy Shaman. I had that title at a credit union and really did phone. I'm assuming you mean phone calls on information in the database. Yeah. Yep. So yeah, and so it removes that layer of abstraction from GUI tools or ORMs or whatever, and it really lets you get straight into that communication back and forth with the database itself. And SQL is often used in large corporate environments. And here's just a few examples. You got Microsoft SQL Server, you got Oracle. Oracle is what I currently use in my day job, PL SQL, IBM DB2, SAP HANA, SAP Adaptive Server, Oracle MySQL, and open source Postgres, which I think Postgres is what we're going to touch on a little bit in 100 Devs eventually. I'm not quite sure when. So yeah, but overall, all SQL is based on one standard. So there is a standard behind SQL itself. However, with these different flavors of SQL, such as T-SQL or PL SQL, they may have slightly different quirks. It's kind of like British English or Australian English versus American English. We have slightly different vocabulary, but we can all understand each other. There may be a few unfamiliar words here and there, but we can all, in the end, we can all basically communicate. So yeah. All right. So how does SQL work? So SQL is declarative. So unlike kind of what we've done so far in JavaScript, where you essentially build out functions and then you call those functions and you're really getting down into the, telling the program exactly what to do and when to do it and controlling the order that it does things. With SQL, you're essentially just saying, you're just giving it instructions. You're telling it what you want, but not necessarily how you want that done. So you're basically just saying, give me these fields from these tables with these criteria. And you're not specifying how that gets done. You're just saying, hey, give it to me, please. So the benefit of that is that it's easy to read and easy to write. So SQL was essentially written back in 1974 before people really had much experience with computers at all. And so it was meant to be easy to dive into and pick up for people that maybe never touched a computer before in their life. And so it kind of reads like an English sentence. When we read it later, we'll see that you can almost read it as like you would a sentence in English. It's pretty easy to follow, but that does lead to some pitfalls, which we will also touch on, that can make it less good. But yeah. So the con of that is that you're limited by the constraints of the language itself. You don't have that granularity of control, and that flexibility that you necessarily would in JavaScript. You're basically limited by whatever is built into the language, the sorts of things that you can do. We're not going to hit any of those limits today. We're going to stay within pretty much the most common types of things you would be doing with SQL. We're not going to be pushing the limits today. Yeah. How do you all pronounce? Yeah, actually, I have a poll. Let me just trigger this poll real quick. Um, Hang on. I have a poll for this. All right, there you go. 3 minutes. How do you pronounce SQL? So click on in chat. Click up top for the poll, and you can vote on. Don't put it in chat. Vote in the poll. I want to see how you all pronounce those letters SQL. Do you pronounce it SQL or do you pronounce it SQL? So you've heard how I pronounce it, but don't let that influence your decision. I'm not saying I'm right. All right, go back to the slideshow here. Yeah, I am Sassy. You can be limited by the syntax with what the limits of SQL is actually able to do. May consider squeakles. Okay. So I don't want to just sit here and read slides at you all day. What I do want to do is dive into some examples and we can practice writing some SQL queries together. So that's what we're going to do. I like Vossi's pronunciation the best so far. Vossi pronounces it seagull, which I actually highly agree with. Yes, I think seagull is the new best pronunciation. Yes, seagull. All right, so if you've got the slides open, you can just click this link. And if you don't, I will just copy the link for you. Let's see if I can, hang on. Nope, that's too far. I'll just copy the links for you and drop it in chat. Thanks, Meticulous. I'm glad that you appreciate my slides. Actually, I use them. I made them using the Google slide creator and within Google Docs, and it's actually pretty nice. I really dig it. Yeah. So that's a link to where we're going. What we're using today is we are using the W3 Schools SQL Try It editor. It's a sandbox where we have a lovely pre-created database, which is you can see over here on the right, and we can basically run whatever we want. And if we screw it up, all we got to do is hit restore database, and all of our data will come back. So that's what we're going to work in. And I'm going to zoom in a little bit. Can everybody see this okay? Can you all see, is the text size large enough for everybody? Who's saying you were just using that same slide template today? That's awesome. Yeah, I like it. Good? Okay, great. All right, I'm just going to pull my notes up over here in my other window. Remember what I'm talking about. Okay, so let's first take a look at what data that we have. So over here on the right, we can see that we have a database, and we have several tables inside of those databases, and each table has X number of records. Oh, okay, let's see. How do you pronounce SQL? What one was SQL? Okay, I wonder if my pronunciation influenced that at all, but 72% of the vote said SQL. So about 3/4 of the folks said SQL, everybody else said SQL, which actually the SQL standard specifies that you pronounce it as SQL, but I think even the creator of the language pronounces it SQL, so so who cares what the standards say? Nobody reads those. Who knows? Yeah. Oh, larger? Okay, I can make it a little larger for you. There we go. I think that's about as big as I can go without, once we start running stuff, it's going to end up off the page. So, well, I think that's about as large as I can make it. I hope that's okay. Mavi says, in Spanish, you say SQL. Ah, okay. That's yet another pronunciation. Yes. So many ways to say it. All right, so we've got our database over here, and we have multiple tables. And inside of those tables, we have X number of records. So what do we mean by records? So records are essentially rows. And so let's go ahead and take a look at one of these tables. We'll look at a small one here. So let's look at shippers. So here we have a table called shippers, and it has 3 columns and 3 rows or records. So in this case, you can see that we have shipper ID, 1, 2, or 3, shipper name, and phone number. And let's look at another one here also. Let's look at employees. So again, we can see that this one is a lot more complicated, but still we have 10 records, and each row or record has a unique employee ID, and that is a unique identifier for the row. So we call that a key. And we'll talk more about keys later, but we've should have already heard of keys when we talk about our like Mongo databases, right? Each document inside the database gets its own ID number, right? And that ID number is a unique identifier for the document. And it's the same here. We have employee ID, which is a unique identifier for the row. So yeah, we've got tables containing all sorts of different information. We have, so we have shippers, we have products, we have orders. And if you notice, looking at like the order table, right, we have, each order has its own unique ID, which is great. And then we have something like a customer ID, employee ID, and shipper ID. So what's interesting here is that we aren't storing all of the, you know, employee information in this one table, right? We don't have like their name or, I don't know, their notes. In the shipper ID, we don't have their name or anything else about them. We just have this ID number. And that's kind of the point of what we do when we normalize a database, right? Is we extract out the information that we don't necessarily need and only leave just the barest basic amount of information that we can use to identify the employee that was involved with the order and the shipper that shipped it. And you might say, well, yeah, that's fine, but what I really want is to know like the name of the shipper that was associated with each order. For example, I don't know what shipper ID 3 even means. That tells me nothing. And also, I don't know who employee ID 5 is. Like, that also tells me nothing. Well, cool your jets, we will get to that. We'll talk a little bit later about how SQL allows us to pull that information in and join it with this particular table to see all of the information that we want to see, but only when we want to see it. Yeah. Yes, exactly, bodega. Yep. So does record equal document in Mongo? Loosely, yes. And table equals collection. So yeah, it's dangerous to necessarily draw direct comparisons between the two. But I mean, if you're from a basic perspective, you can kind of think about it that way. A collection is basically, well, it's a collection of related documents, right? Of documents that somehow relate to each other. And a table is basically a collection of rows which all contain the same information. Yeah. So tables tend to be much more strict as far as like their contents. But yeah, as a rough comparison, I think that's reasonable. Yeah. Yeah, a record is analogous to like a document. Yeah. Thanks, HJ. Yeah. I don't think I forgot any comments this time, but I have plenty of comments, but they're only verbal. Yes, that's true. Okay, so we're going to explore these tables in more detail later, but for now, let's just talk about how to actually write some code to deliver data out of these tables. So let's look at products. All right. So there's a lot of information inside of the product table, right? We have an ID, we have a name, supplier ID, category ID, and a unit. Well, that's fine, but there's a lot of products in here. Let's say I only want to look at products that have a price that is less than $20 or 20 whatever. So we can see that the default query here is just select star from products. And what this is saying is give me all of the columns from the products table. That's all that's saying. Okay. However, what we can also do here is we can specify certain filter criteria that will allow us to narrow down the number of rows that we return. So right now we can see that I'm getting 77 rows, 77 records back from this query. So if I want to narrow this number of results down to only things with a price of less than $20, all I need to do is say select star from products where price is less than 20. Okay, so what did I say there? I'm applying a filter saying, all right, give me these columns and all the rows that match them where the price in the price column is less than 20. So let's run it and let's see what we get. Okay, so now I get back 39 rows. And so essentially all this is doing is it's just applying a filter to the data. Yeah, and that's a great question, Hertz. Does it have to be caps? So in general, there's a joke about SQL developers that we all write like we're yelling all the time because the standard for SQL is that you do write in all caps. However, it's kind of like certain things in JavaScript where it's suggested but not required. I think with SQL being such an old language, back in the day, everything was always in caps because that's how computers displayed text, right? Computers always displayed everything in all caps all the time. But now most editors, including this one, they do not care if you write in caps. So you'll probably see me be pretty sloppy about that as we go along. I'm trying to be careful right now, but I'm sure I'll mess up later. But yes, that's a great question. It is what's considered the standard way to write SQL, but it is not required. It's not case sensitive. And I don't know that I've really ever worked with an editor that really cares. If your editor has like autocomplete, it'll probably try to autocomplete things to caps, but nowadays like SQL editors are really intelligent and they can tell what you're trying to say. Yeah. So we were able to filter our results by the price column. And we can do all sorts of manipulations here. We can say, well, all right, what about where price is equal to, say, 10? Let's try that. So now we get back far fewer records, right? Because we set only where price is equal to 10. So there's only 3 that have that result. Yeah, and that's a great question there. Yeah, so that's a great question. The star means select all, and the star is basically analogous to a wildcard. It's a wildcard character. It basically means grab everything. And we'll talk about how the different things we can do with this in a minute. But yeah, so right now we're not concerned with filtering the columns that we get back. We're just focusing on the rows for now. Yeah, it's a wildcard like DOS, indeed. Yep, same usage basically. Okay, so price is equal to 10 only brings back 3 rows, right? And we should be familiar with these types of filters of less than, greater than, equals, right? It's pretty much the same in JavaScript, except for we don't use multiple equal signs. We don't do something like that. All we need to do is just the single equals, and that will bring us back what we're expecting. So it's a little easier in that regard, I guess. Does the table name have to be in square brackets? That's another great question. So the way this editor works is that every time you click on a table, it always puts it in brackets. However, the brackets are not necessary. You can leave them there. It doesn't hurt anything. Basically, what the brackets do is if you did have a table name with like a space inside of it, it would act as a delimiter that would tell SQL that this is a single table name, right? But in this case, it's not necessary because all these tables are just single words. And generally, you're not going to encounter table names that have a space in them. That's just bad form. So, I mean, it's good to know what it's for, but you don't need it in this case. Yeah. All right, so we've got select star from products, and we can use the where keyword to apply various filters. So we've done a couple filters on numbers, but let's say that I wanted to do a filter on a word, such as product name. So I know that everything in here, in this table, in this column, is essentially a string, right? It's words. So how do we identify a string in JavaScript? How do we tell our code that something is a string? Bunny ears. Yeah, we use quotes, right? We use quotes to identify strings. Yeah. So, and we can do the same thing with SQL. SQL also recognizes that quote marks mean that something is a string. So in this case, let's say I want to find, there's a product in here with the name of Long Life Tofu. And let's say I just want to go straight to that row. I don't want to have to like scroll through here and figure out, okay, which product ID matches with Long Life Tofu. I don't want to do that. I just want to go straight to the product name of Long Life Tofu. So I'm going to say where product name equals, and then I'm going to use a quote mark, single quote, Long Life tofu. And in this case, I can put a space because it's inside of the quotes, right? And so our code is going to recognize that anything inside of the quote marks should be treated as a single string. So let's try that. There we go. And so that let me filter straight down to the product with the name of long life tofu. Yes, indeed, quotes. Yes. Yep. And so we can see that like this is the same as what we've learned in JavaScript, right? So some of this stuff carries over. Some of the things that you're going to see here are things that you'll recognize that you've already learned as part of JavaScript. For example, using less than or equals to match with numbers, or using quote marks to match with strings. Like these things are universal. So that's kind of cool, is that once you've learned one language, you can start to recognize things in another language that will help you learn it faster. So let's try. Some editors can be different than others. So let's try double quotes and see if it works. Yeah, in this case, it does work. So this editor is going to allow you to use single or double. Some flavors of SQL are more picky than others. In this case, it doesn't appear to care, so you can use double quotes as well. You'll probably see me use single quotes just because that's what I'm used to using. But yeah, in this case, both will work. Yeah. Okay, so now let's think about this. Let's say that I remember that there are some tofu products in my product list, but the thing I don't remember is exactly what the name of those products are. It's like, yeah, I know there's something called something tofu. I don't know exactly what it's called. I just want to look for every single product that has tofu in the name. And so we can do that. And but this time, instead of saying equals something tofu, we can say where product name like, and then again, using quotes, we can use a percentage symbol to, actually I'm going to capitalize this, tofu. We can use percentage symbols to essentially say, okay, SQL, please look for something that has tofu in the name, and then it's okay if it has other text on either side of it. So in this case, it can have extra text on the left, and it could potentially have extra text on the right. We just want something with tofu in the name somewhere. So let's look for that. Yeah, so in this case, we can see that there's a couple products. There's one that's just called tofu, and it has nothing on the left or right, and that's okay. But then we also found the other product that we looked at earlier, which was long life tofu. So there was text on the left side of the word tofu, and it still brought it back. And so you don't have to memorize all this stuff. Just know that there's ways that you can look for exact matches, and then there's ways that you can look for partial matches as well, and it's pretty easy to do so. It's like, yeah, exactly, Rascal. It's like regex, but not nearly as terrifying. Yeah. And so that's what I think is pretty cool, is that SQL, once you know these things, SQL can make it pretty user-friendly to do these types of partial match searches and to essentially search through massive amounts of data pretty darn quickly and get back what you want pretty darn easily. So yeah, it's like regex, but not nearly as terrifying. Exactly. Yes. So why no wildcard for this? Well, there's no harm in trying, right? I don't think this is going to work, but yeah, no result. That's just the way that strings are. That's just the way that you format strings when you're searching for partial matches. Just using the percentage symbol. That's just how it works. I don't know why, but there you go. Yeah. So feel free to mess around with this a little bit. Try doing a select on whatever table you want and specifying a where clause on a certain column, and then either looking for an exact match with an equal sign, or looking for a partial match on a string with the like keyword, or bringing back a range of numbers using the caret symbols. You think some flavors use wildcard and question mark to match their regex counterpart, like MS Access? Yeah, yeah. And that's one of those differences in the flavors of SQL, versus like Oracle or something, which uses the percentage symbol. Yeah. So yeah, feel free to play around with this a little bit. We're going to do a little bit more here. We're going to add just one more level of complexity here. So we can use a where clause where product, let's go back to something like where price is less than 20. So we'll run that. And again, we get back our 39 records. But what if I also want to look for things with, let's say, a price of less than 20 and let's just pick something, a category ID of 4. Okay, so I can specify multiple filter criteria very easily here. I can say, and supplier ID, let's just say supplier ID equals 4. Okay, I only get one record back this way. And I did not plan that. I did not know that it was going to bring back the same thing again. Let's try a different supplier ID. It brought back it just knows I really like tofu. All right, there we go. Oh, that's weird. Louisiana hot spiced okra. What even is that? That's wild. Yeah, yum indeed, I guess. Yeah. So yeah, you can specify multiple criteria in your where clause very, very easily just by saying and. Again, this is kind of, SQL was written to read very similar to English. And so if I wanted to say, if I was speaking in words and I wanted to have a sentence with multiple components, I would use the word and. And so in this case, if I want to specify multiple criteria in my where clause, I can just literally type the word and specify more. I could keep specifying ands here if I wanted and use, different criteria each time. And it would read that and bring back the appropriate result with all of those filters applied. So, I think to me anyway, it's fairly easy to just look at this and kind of understand what's happening without too much, prior knowledge. So, IM says, yeah, you can see how this would be a very powerful tool. Indeed, it is. That's why it's stuck around. That's why it's stuck around for almost half a century. Is just because it is extremely powerful. Interfacing directly with the database, just basically telling it what you want, and you get back exactly what you were looking for. Now, with great power comes great responsibility, as Spider-Man has taught us, right? And so we'll talk a little bit later about how the way SQL is written can also allow you to make mistakes pretty easily as well. But generally when you're writing a select statement, you're pretty safe. Because if we think about how you interact with a database, we're in the R of CRUD, right? If you know what CRUD is, create, read, update, delete, we are just in the read part of CRUD. And so we're not actually making any changes to the database itself. We're just pulling data down so that we can look at it, right? Yeah. Okay, so that's a where clause with multiple criteria. Now, somebody asked earlier about, actually, wait, before we go there, let's keep this as is. Except I'm going to increase the price so we get a few more results back. Price less than, let's say 50. Let's see if we get it. Yeah, all right. Okay, so when I increase the price, I get a few more results back. So now I have 4 results. And let's say that I want to put these results in descending order of their product ID. So I want to see the one with the largest product ID first. Or no, let's do price. Sorry. Let's do price instead. Let's order by price. Let's say I want to, if I was looking at 100 records, and I wanted to put them in order of price from lowest to highest, I can also do that very easily. $17 is pretty cheap for 24 jars of okra. I think that's unit price. And we'll actually look at that a little bit more later. Yeah, I believe that's unit price, but we should start a grocery store, indeed. Yes. Okay, so let's say I want to put this table in order. I want to order by the price column. So any guesses on what I might type if I want to order my results by the price column? Don't think too hard. Similar to Express, SQL is written in a very generally in a very intuitive way. Yeah, Neon is correct. All we need to do is say order by. We don't want to change our where filter, right? Because I'm happy with my results. I just want to order the results by the price column. And I want to order it in ascending order. I want to order it in ascending order from lowest to highest. Yes. So all I need to do there is type the word ascending. Actually, I'm going to capitalize that. There we go. Order by price ascending. So now when I run it again, I am now ordering by price from lowest to highest. I am saying now now I know why you said don't overthink it. Exactly. Yeah. Yep. It's plain language, plain English. Generally, what you see, what you get. For simple queries, it's very what you see is what you get. And so what we did here is we have our select. We're selecting all the columns from the products table where the price is less than 50 and the supplier ID is equal to 2, and we are ordering it by price in ascending order. Now I could also say price descending and get the reverse. So here, highest price first and going in descending order. Now, the one thing to consider here is that the order of statements, the order in which you type the components of the statements is important. Let's say that I wanted to, let's say I just move this order statement up here. I'm going to put it second. I want to select from products, order by price, and then put my filters on. So let's do that. Uh-oh. I get an error. So the order in which you write these things does matter. So let's put it back. So in general, your command of what you want to do comes first, followed by your filter criteria and all of your criteria if you have multiple, and then any ordering or grouping statements come at the very end after your results have already been filtered. Yeah, so you'll get the hang of that. You might mess it up here and there, but it'll just immediately give you an error if there's a problem. So feel free, make mistakes, get messy, like Miss Frizzle says, right? Make mistakes and get messy and just try stuff and see what happens. Okay, so let's run this again. Yep, and so we still have our price. We're filtered by price descending. And now, all right, so this is all well and good, right? So we have our results set back, it's filtered, and it's ordered in the way that we want. However, I have some extra information in here that I don't particularly care about. If I was just wanting to get back a very small, compact result set, I don't really necessarily care about like the category ID. I mean, I might care about it later on, but right now I don't. This 2 means nothing to me. I don't care what it is. I don't necessarily want to see it. And also I don't really care about the supplier ID. I used it as a filter, but in the end, it still doesn't really tell me anything. I know that I'm filtering on supplier ID equals 2. And so I know that everything I get back in my results set is going to have a supplier ID of 2. I don't need to see that. I know it's there. I've checked it. It's fine. My filter is working properly. I don't want to see that. And I also don't really care about the product ID. Really, all I want to see in the end is the product name, the unit information, and the price. So I can further refine the results that I get back by controlling which columns I'm requesting that I get back from the table. So previously, we had just said select all columns using the star, select all columns from the table. But I can also control specifically which columns I want to select out of that table. So I'm going to say I want product name, unit, and price as the only thing that I get, the only 3 columns that I want back from that table. So now when I run my SQL, That's all I get back. I just get the product name, the unit, and the price. So very simple. I'm just specifying exactly which columns I want, which table I want to get them from, my filter criteria, and then once those results are prepared, how do I want them displayed? In what order do I want the results displayed? So it's a very logical progression. And the more you do it, the more logical it gets, the more practice that you have. So this is basically, I mean, this is the bread and butter of SQL, is select statements. That's what if you have to just query data for a job where you're not directly developing SQL, this is probably what you would be doing a lot, whether it's, data science, data analytics, even, a non-SQL developer role. You might occasionally just have to touch a database and just pull data out of it. And so select statements are going to be your bread and butter. So knowing how to do these things will be very, very beneficial for you. So I'm going to hydrate and do a posture check. Thank you. Any questions so far? Go ahead and see if you can write a select statement with, see if you can choose another one of these tables and select a few columns out of it, and then apply a filter to your results, and maybe order by one of the fields that you get back. And you'll notice that in the end, even though I'm filtering on supplier ID, I didn't have to display it. I could just have it as a filter without showing it. And so that's kind of a neat feature, is that you can apply filters on fields in the table that you don't even end up displaying. Yeah. So any questions? And for those of you who may have just joined us, I'll go ahead and share another link to this sandbox so you have it. If anybody's new, feel free. This demonstration is meant to get your hands dirty and practice some things. That's a great question. Is it common to type line by line like this? So yeah, that's a great question. Some people do all their SQL in like one line. Those people are monsters. No, I'm kidding. In general, you want to kind of space out your SQL like this, having your select and then having your column list on individual lines, and then having each component on its own line. Yeah, it's not required. Your SQL will still run if you put everything on one line, but it's just much harder to read that way. If you type it out like this, it'll be very long, but it will also be very easy to read. Yeah. Rascal says, but my Code War SQL solutions don't look as impressive on multiple lines, right? Yes, yeah. You can, like I say, there's nothing stopping you, but it's going to be really hard to read that way. Yep. MD Rez says, what is the difference between SQL and MySQL? So I mentioned earlier that there are many flavors of SQL. So SQL itself is like the overarching umbrella. It's a standard language. But then also, of course, as companies often do, they came in and they grabbed the language and they said, yeah, I'm going to take this, but I'm going to do stuff to it to make it work better for me. I'm going to add features. I'm going to change things. And so that's why you end up with these individual flavors of SQL, such as MySQL or T-SQL or PL-SQL. And they're all, sort of owned by different companies, and they don't necessarily play nice with each other. However, if you know the basics of SQL in general, you'll likely be able to work with whatever flavor of SQL your company uses. So for example, I started out learning, well, actually, I don't even know what flavor of SQL I started learning. I didn't know there were different flavors when I first started learning SQL. However, by my second job, I was learning T-SQL, which is Microsoft's flavor of SQL. And then now at my current job, I use PL-SQL, which is Oracle's flavor of SQL. So I didn't really have a lot of trouble switching. There's some annoying things that are different between the two, but really it's not bad. So Motherboard, insert XKCD 15 complete competing standards comic here. Yes, I know exactly which one you're talking about, and it's very true. Somebody tries to introduce a new standard that's supposed to unite all the existing standards. All they do is end up creating another standard. Yeah, exactly. Neon, and that's a fair point. You prefer to have all your selected columns on one line since it reads more like a table heading, and that's perfectly fair. It's more about what is most readable to you. What are you, what are you gonna, what's gonna be most accurate for you and most efficient for you? Yeah. Yep, exactly. Okay, so this is the bread and butter of SQL, which is the select statement. And what's really remarkable about these select statements is how they can really help you drill down. Like when you start working with real data in real databases, you're often going to have tables with literally millions of rows. Like this is your little practice database where the largest table is 518 rows. That is nothing. In real data, you're going to have tables with millions of rows or hundreds of millions of rows, and really the select statement is your bread and butter to filter those rows down into something you can actually work with. But in general, and in general, a lot of times what I will do if I'm unfamiliar with a table and I'm not quite sure what the data looks like, I will start out with just a select star from products. I just want to see the data, see what it looks like, and then I can start applying my filters because I'll know visually, okay, here's what I'm working with. And somebody asked, how can someone bust into this field? Need to make a change while I'm going through 100 devs. I mean, how I got into it was I got a data analyst job that actually required us to use some SQL to pull data from a database here and there. It was not the primary focus of the job by any means. It was really just a tertiary thing. Is just, oh yeah, and occasionally you're going to have to touch the database to connect up these dashboards and pull down some data so you can actually use it. And so that's how I learned to write select statements, and that's really all I did for the longest time. For like a year, all I did was just select, 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 select. And so that's it can be a component of a job that you get, and then you kind of slowly transition into that field. But SQL is so widely used that you find it as a component of a lot of different jobs, even if they're not straight developer jobs. Techie, I mean, I got into data analytics. I straight out of college. I had a stats degree. I mean, but it's data analytics is a really wide field, and it touches a lot of different disciplines. So it's not like you need a certain degree for it, or even that you need to have a certain background for it. It's a very wide field. I would say if you have you need to have a decent knowledge of analytics tools such as like Excel, or having some knowledge of SQL is great. Having I would say at minimum having a good grasp of advanced Excel and maybe other visualization tools like Tableau, that can be really helpful. Purple, are we going to drop some tables? We're going to practice some delete statements later, and I'm gonna have some homework for you about dropping tables, but we're not actually gonna drop a full table together today. That's a bridge too far. But we are going to talk about what it means. Okay, so let's see what's next. Does anybody have any further questions on select statements before we move on a little bit? Well, that's why we have this little restore database button right over here. This is our safety net. We're gonna deliberately screw some stuff up later, and we're gonna use this button to bring it back. Okay, well, it's 4:06, so I think it's time for a break. We like to take a break about once an hour, to stay healthy and to stay hydrated. So I think this is a great time for us to take a 5-minute break. And I will see you back after 5 minutes. If you would like, feel free to keep messing around over the break, or get up and stretch or whatever you need to do. But I will set the timer for 5 minutes, and I will see you all back here shortly. It's actually the timing on this worked out really well. All right. I can't type. 5-minute timer. There we go. Okay. Right. See you back here in 5. Okay, folks, come on back. We got about 45 seconds left, so mosey on back when you're ready. Hydrate or dihydrate, indeed, Chris. Yes. Yeah, Edward. That PHP query sounds very similar. Yeah. some other languages, borrow the syntax from SQL without being real, like actual SQL, but they borrow the syntax. Yeah, that could be what's happening there. I'm not 100% sure. Alrighty, I'm gonna go ahead and stop the timer. 5 seconds left. Stop it and minimize, and let's get back to it. Okay, so I'm gonna turn my webcam back on too. Okay, there we go. And we're back. All right. So, earlier we were kind of talking about how these tables are, very clean. They really only have what is necessary for the basics of the table, right? So we have the product name, we have the supplier ID, category ID, etc. But what if I actually wanted to see the name of the supplier in my results? I wanted to select from products, but then also include the name of the supplier. However, the supplier name is in a different table. It's in this table called suppliers, right? I can see the supplier name is here in the supplier table. But however, if we just look at this, if I look at products, I can see that there's a supplier ID. And I look at the supplier table, I can see that there's also a supplier ID here. That looks like a link, doesn't it? A link of some kind. Yes. And this identifier of supplier ID is unique for each supplier. So theoretically, if I could somehow, from this products table, link it to the supplier table on the supplier ID, then I could pull out the supplier name for each line here, right? Theoretically, I could do that. And now we're getting into kind of the main power of SQL, which is something called joins. So joins happen when you take one table and link it to another table through these unique identifiers, usually. And the unique identifiers are called keys. So in this case, in the supplier table, the supplier ID is a key, a primary key, which is a unique identifier for each row. And the supplier ID that's listed in the product table is called a foreign key because it identifies the key from another table. So you don't have to understand this yet. Just remember that a key is a unique identifier that specifies a unique row in a table through some way. Sometimes it's numeric, sometimes it's something else, like a code of some kind. But just remember that this is in the context of a relational database. This is a key. It's a unique identifier for something, right? Inadequate. Oh, you missed the start. That's no problem. You can catch up if you want. We're not super far into it. We've really just gotten through select statements. So, I mean, if you already know select statements, you're welcome to follow along. Or if not, that's fine. You can definitely catch the VOD. Either way is cool with me. Okay, so we have these unique identifiers, and we kind of know conceptually that it feels like it should be possible to link these two things together. And so the power of SQL is that it lets us do that. And that's done through something called joins. Okay, and there are a few different types of joins. We're not going to focus on all of them today. We simply don't have time. But in general, joins allow you to literally join tables together and return a single data set or result set that contains fields from each source. So if I want to list out the products and then pull in the supplier name from the supplier table and have them all show up together in that wonderful, result format, I can do that. And keys, like we talked about, they allow us to match together and return unique rows. And what type of join you use will depend how many rows are returned and whether blank rows or sorry, or I should have said blank columns are included in the data set. Okay, so we can see that there's a few join types listed here. And I'm a very visual person, so I like seeing these things in visual form. But in general, there's 4 types of joins. The first one we have here is inner join. So if I'm inner joining 2 tables together, I'm only going to return the fields that are common between both tables. Oh, good. I'm glad you like the visuals. Yes. Yeah. So if I have, and I'll show an example of this here in just a minute, but in general, if I have 2 tables and each of them have, slightly different data in them, depending on what field I join on, the result set that I get is only going to have the fields that are common between both tables. The left join is going to take the first table. So if we're thinking about our example, we have our product table, and it's going to return every single row from that table, based on whatever filters we have. It's going to say, all right, I'm going to grab everything from this product table, and then only return the matching rows from the supplier table. So you may end up with some blanks in there if you don't have enough suppliers to match all the rows in the product table. But it's going to essentially blow out the results from the supplier table to match as many rows as possible in the product table, leaving blanks should they appear. And then right join, essentially, these 2 are less common, right join and full outer join. They're less common, but just know that right join is essentially the opposite. It returns all the results from table 2 and only the matching results from table 1. And a full outer join returns all possible results from both tables, basically matching or not, and it's not something that you generally want to do ever. I mean, there's I've seen it applied a couple times, but it's more like that. This is more often something that you do accidentally, and then you get way too many results back, and the database administrator gets mad at you and ask me how I know. I have absolutely done this before, and the DBA got mad at me. Because, yeah, so the most common joins are going to be these 2, inner join and left join. And which one you use really depends on the types of results that you want. Do you only want the matching rows from both tables and basically making sure that you never have any nulls in any of your set of matches? Or do you want literally all the results from table 1, regardless of whether it has a match in table 2? These are really going to be like these 2 are going to be the ones that you're probably going to use most often, and they're going to be the ones that we're going to do some examples on here in just a little bit. We're not really going to pay attention to these 2, just know what they are, and verbally be able to kind of articulate them. But the ones you should know how to do are inner join and left join. That's a great question. I am Sazi. Yeah. Okay, so let's look at some examples of what this actually means. So starting with left join. All right, so left join. Let's say I have 2 tables. I have a table called orders, and I have a table called customers. And what I want to see a list of all the orders and the customer name associated with each order. Okay, so I want to list out all of my orders no matter what. And I want to see a list of each of the customer associated with each order. So let's look at our customer table here on the right. So I can see that I have some customer IDs here, and they go 1, 2, 3, 4, 5, and 6. However, in my order table, I have some customer IDs here such as 7 and 8. So if I try to match these 2 together on customer ID, there's a couple that aren't going to come back with matches. So, just visually looking at the data, we can see that. But I'm okay with that. I don't mind that. I still want to list all of my orders no matter what. And it's okay if there's blanks on the customer name because it didn't find a match. So in that case, since that's the kind of data that I want, I'm going to use a left join. So in that case, my query would be something like this. Select everything from the order table. Whoops, sorry, hang on. Select everything from the order table. Select the customer name from, oh, and I realized I missed a line there. I should have said customer ID and customer name. Left join customers. And we're doing that join on the customer ID. So we're saying, hey, SQL, please match the customer ID in the order table with the customer ID in the customer table and return the results. So in the end, what we get is all of the orders listed out and then all of the matching fields from the customer table listed out as well, but with blanks where it was unable to find a match. Okay? And we'll practice this. It'll make more sense once we actually practice this. But in general, this is what it's doing when we do a left join. It's saying, all right, give me everything from table 1 and then the matching values from table 2. And discard anything that doesn't fit and leave blanks where it couldn't find a match. Now, inner join is going to be slightly different. What inner join is going to do is essentially match on customer ID still. We're gonna do another match on customer ID, but any fields where it can't find a match, it's going to discard those. So if we look here, we get back a very similar data set, but any fields that don't find a match aren't returned because an inner join only looks for fields that match between both tables, okay? So in this case, the fields with a customer ID of 8 and 7 are not returned at all. And so what we end up is a result set with no blanks at all. This is a cleaner look, I am Sassy. Yes, and sometimes that's what you want. Sometimes you're like, look, I know my data set is incomplete and I can't get viable results with incomplete data. So I want to discard anything that is not going to give me back what I want. And so you would use an inner join there. However, sometimes you don't want that. Sometimes you're like, look, I know my data is incomplete, but I still need a complete list of records from table 1. I don't want to discard anything from table 1. That's my basis. That's like where I'm getting my counts from, or I don't know, revenue or whatever. And I want to just pull in whatever fields I can, whatever fields I have available from table 2, knowing that there may be some blank rows in the end. So it's more of a judgment call. It's not saying that one is right and one is wrong. It's more about what data do I want back? What results do I actually want in the end? So, and we'll practice this, and we'll see a few of the differences between these types of queries here in a little bit, and what kind of filtering SQL does when you specify a certain type of join versus another type of join. But yeah, you're right. It is cleaner, and sometimes that is what you want. Sometimes you just like, look, I want a complete data set, and I want to scrap any rows that don't have matches. Yeah. Okay, so let's get away from the slides and let's do some examples. But real quick, before we do that, before we go back to the examples, does anybody have questions on just like the basic concept of what a join is, what it's for, and the potential types? Y'all are chomping at the bit to do some examples, I can tell. I'm gonna hydrate real quick. Ooh, that's a great question, Neon. So Neon asks, is there a reason that left join is usually used instead of right join? Just in general, when you're running a query, usually you start with like your base table, or the table that you want the most information from. So when I'm writing a query, I usually start with doing a select on the table that I know has most of the fields that I want. I'm going to, maybe be pulling like 10 columns from that table, and then maybe I only want 3 columns from table 2. So I'm going to start with table 1, and select all my columns, and then I'm going to treat that as my base, and then I'm going to bring in table 2 and just do a left join, knowing that I still want all the majority of fields from my base table, and then whatever I can get out of table 2. And so, I mean, you might use right joins more when you're daisy chaining multiple tables together, and you can do that. You can do joins on more than one table or more than 2 tables. You can, keep joining and joining and joining. It just gets more resource intensive as you do so. Yeah. Mavi's asked, so left join gives you all the values from the original table, even if there are no equivalents in the second one. Yes, exactly. Yep. Yep. So it brings in all values from table 1, and then really whatever matches from table 2 without caring, about the things that don't match. Yep, exactly. Yeah, so the main table could be considered the primary, where the other's a secondary. Yeah, I mean, in the terms of left join, yeah. I almost like to think of it as, when I'm thinking about left joins, I think about table 1 as like a wall. It's like a brick wall. It's not changing. And then I think of table 2 as like a scissor lift that like can go up and down and expand to fit the height of the wall, right? It's table 2 has to be the flexible one in this case, and only give us back the results that actually match. That's probably a weird way to think about it, but that's just how my brain works. Yeah. Uh, yeah. Roshan, yeah. So left and right join are technically the same mechanic. If you're changing the order of the table. But I would say left join is just much more common because you tend to start out with your base, start doing your selects from your base, and then just bringing in the second table to give you the remainder of the information that you need. Yeah. D-Rox, that's a great point. As far as like the cleaner look, thing about having why would we want any blank rows at all? Yep. So think about an accountant who needs all of the orders to add up, even if a customer has closed his account since making the order. So a customer may not even be present in table 2 anymore because they've closed their account. However, if you're looking at historical revenue, all that revenue still needs to add up. So you still need all the fields from table 1. Yeah, absolutely. That's a great example. Oh, Ian Gregory says, that's interesting. Right join is typically used in EU countries. Okay. Yeah, that's a great, I did not know that. That's awesome. So yeah, and in this case, the mechanism is the same. Yes. And so we talked about normalization just as a general concept. We aren't going in depth on it, just knowing what it is and what it's for. That's really all we talked about there. Normalization. Okay, so let's do some examples and we'll practice doing some simple joins and see how they look. Yeah, and D-Rox, that's another great point. The base table, so your table 1, is generally where you're doing your filter. So you're like your where clause. So you're sort of setting the scope of your results on table 1. So how many rows in general you want back. That's where you're setting your where clause, and then your table 2 you're bringing in as supplemental information. Would Australia be upside down? Bottom join. Yeah. Danny J, yeah, I suppose it is kind of like VLOOKUP, right? Because you're starting with your base, which is generally like a list of data, and then you're taking a second data source and you're looking up against that and only returning matches. Yeah, I suppose that is a left join. I hadn't thought about that. Yeah, that's really interesting. I use VLOOKUPs all the time and I never made that connection. Wow. Huh. Yeah, I think you're right there. Let's see, I'm making sure I didn't miss anything else. Okay, let's do some examples. All right, so we're gonna go back to our little sandbox here, same place we were before, and pull my notes back up here. Oh, Elchie, I'm glad that worked for you. Yeah, I'm glad that was helpful. Oh, yeah, thank you, Sirota. Yeah. I've actually never, done a lesson on SQL before, so um, I'm a little, normally I talk about JavaScript or in JavaScript related things. So I'm glad this is landing for people because this is my first time ever talking about it in an educational concept. So, or context. So I hope this is landing for folks, but yeah, kind of out of my usual lane here. Okay, so let's try and do a join. So let's go back to our product table. And I know that actually no, let's do this instead. Let's see. Let's look at the order details table. This is a good one to look at. So order details is kind of an interesting table. So order details has an order detail ID, which is a unique identifier for the row. And order ID is the order ID. Okay, fine. And then we also have a product ID and a quantity. So let's say that I wanted to learn essentially what products are my biggest sellers from quantity and which products bring in the most revenue. So how many, like what's the max quantity of products that I sell, like what are my highest volume movers, and which products bring in the most revenue? Is it the same products that have the highest quantity, or is it products that have a higher unit price? This is a pretty common question to ask when you have a business, right? Like you might have something that has a high volume, but it sells for a very cheap price, and so it's really not bringing you in very much revenue at all. So I think this is a pretty common question and a good one that we can figure out how to answer. Okay, so we're going to start with order detail as our base table here. So order detail contains a couple of fields that we want. One is product ID and the other is quantity. However, if I want to find more details about each of these products, like their product name and the price, I'm going to need to look inside of the product table. So here we have the product ID, the product name, and the price. So I'm going to need to do a join to the product table to get this information. Now, if I want to make sure that I get a true count of the full quantity of each product sold, what type of join am I going to want to do? Similar to the accountant example that somebody mentioned earlier, if I want an accurate count going back through time, disregarding any products that may have been discontinued, what type of join am I going to want to do? Okay. Yeah. Okay, we got a couple different opinions here. So remember, what's the catch of an inner join, right? If an inner join doesn't find a match, so if I start with the order details table, and let's say I've discontinued a product and it's no longer in my product table, then an inner join would disregard any rows in this table that are associated with that product. And so that quantity would be lost. It would not be returned in the results set. So in this case, what I'm going to want to do is a left join. I'm going to want to preserve all the rows in my order detail table so I can sum the quantity accurately and then match to the product table and get that information if I can. Yeah. So that's an interesting question, Ann Silva. Order details table looks like a table that associates all other tables. What do you call that type of table? So it depends on the type of approach you take to database design. We're not going to get into this, but if you're using the, like, I think the Kimball methodology, where you have facts and dimensions, you would actually call this a fact table. This table contains transactional level details, and then any other table that has more like attributes of each component of the fact table would be called a dimension. But we're not going to get into that. That's high level database architecture stuff. So yeah, great question though. But in general, no, these are just tables, and they can relate to each other through keys. Yeah. Okay, so let's figure out how to do a join. So for now, we're just going to keep it as a select star from order details. Okay. And select star from order details. And I'm going to do a left join here. Left join products. And I need to tell my SQL code what field I'm actually joining on. Because if I just say left join products, it's going to be like, yeah, all right, fine. I don't know how to link these two tables together. It's not smart enough to know that. You have to tell it, I want to join these two tables together on a specific field. And in general, you're going to be joining on the key of your target table. So if we recall, the key in products was the product ID. So what I'm going to do is join on, so left join products on order details dot product ID equals products dot product ID. You ran yours too early. Did you get an error when you ran it, Hertz? Yeah, so we need to specify what field we want to join on. And in this case, we know that our order details table has a field called product ID, and our product table also has a field called product ID, and those two are built to coordinate with each other. They're built to match each other up. So we know that we can join on those fields. And I'm just going to go ahead and run this. Okay, and let's just see what we get. We're going to do some additional stuff with this, but for now, let's just see what we get back. So what do I get back here? First, let's look at our record count. Number of records is 518. And I can see that that matches the record count of my order details table, right? Because the nature of a left join means that I preserve all of the rows in my base table, and then I match, where possible, with rows from table 2. And so I know this data in this database that we have here, this sample database, is very clean, and so we're always going to get a match. But that's not always the case, and we'll demonstrate that a little bit later. But yeah, so we can see that I got back 518 records exactly as I expected. Froze your browser for a few moments. Yeah, I didn't like that. Yeah, if you didn't specify your join data, yeah, it's not going to like that. But yeah, so now we can see that what I get back is essentially a combination of fields from both tables. I have all of the original fields from the order details table, plus all of the fields from the products table. And that's not necessarily what I want, but it's a start. Yeah, all rows are returned from the left table without a where clause. Yeah, we're gonna do some filtering, and we're gonna do some manipulation on that first. But we're making sure that our join worked properly. It looks like it did, because I've got all sorts of lovely matches here, and my record count did not change. So that's exactly what I would expect from a left join. Okay, so now let's refine this result a little bit, because I don't want all this stuff. This is too much stuff. I only want certain columns from each table to build my result set. So just like before, I'm going to specify which columns I actually want. Okay, so really what I want is, I just want, let's do order details dot, actually, hang on. Let's do this first. Let's do product ID. Product ID. And for anybody that knows what's going to happen here once I run this, don't spoil it. Let's do product ID, quantity, product name, and price. We'll just do those 4 fields for now. Okay. So I want product ID, quantity, product name, and price. Perfect. And so this is going to clean up my result set quite a bit. So let's go ahead and run it and let's see what happens. Oh, what? I got an error. Why did I get an error? What does it say? Error 1, could not prepare statement. Ambiguous column name, product ID. Anybody know why did I get that error? Why did I get an error on product ID? It's a field. We know it's there. We saw it. Heck, we're joining on it. Yeah, and Junathy is correct. Yes, because the column name is ambiguous because it exists in both tables. Our code, our compiler here doesn't know which table we want. Which table do you want that column from? We don't know. It doesn't know. We didn't specify. The column name is exactly the same in both tables. Yes, it's defined on both, so you need to specify which table you want to pull it from. Yeah. Yep. Now, why didn't it give us an error on any of the other columns? Why didn't it error out on quantity or product name or price? Why did it accept that? Yes, because they are unique. It exists only once. These 3 fields exist only once between both tables. So there is no ambiguity. Exactly. Yeah, you all got it. Exactly. All right, so let's fix that. Now, there's a couple ways that we could do that. So one way that we could do that is by taking each table name and pasting it in front, using using dot notation. So doing like this and saying like, okay, I want product ID from order details, and I want the product name from products and the quantity from order details. This looks a little bit clumsy, right? Oh, thank you for the raid, Becca. Welcome in. Welcome. We are practicing some SQL today. It's good to have you. So yeah, stick around if you want to learn some SQL with us. We've learned select statements, and we are just getting started on joins now. So welcome in. Thank you for coming. But this looks, putting order details dot whatever and like putting the table name in front of literally every single field feels a little bit clumsy, right? It feels like a little bit like, I don't know, long, especially if you had a really long table name. And sometimes table names can get super long. And so, yeah, it's very verbose. That's a great word. That's the word I was looking for. So what we can do instead is we can do what we call aliasing. So we can rename order details and products to be something much shorter. Rascal said the most obvious solution is to take one of the tables and rename the column itself. Yes. No. Let's not do that. Instead, let's make it much easier, and we're just going to create an alias for each of these tables. Generally the alias is like 1 or 2 letters. And so you can use whatever aliases you want. Some companies will specify how you alias. But in this case, I'm going to use T1 and T2. And so that's going to essentially tell our program to treat order details as T1 and recognize it. It's basically like it's almost like setting it to a variable. It's almost like setting it to a variable. So we're saying, let T1 equal order details and let T2 equal products, right? And so now, instead of having to type out order details every single time, I can just say T1, T1, T2, and T2. I think those are the right tables, yeah. And I can also replace it down here as well. I can say T1 and T2. That makes it a lot easier to write and a lot easier to read. So now let's try this again and see. We should have gotten rid of that ambiguity error that we had before. Yeah, so readable, as far as what makes an alias readable, it's really whatever you want. You might see some people use the abbreviations of the table name itself. Some people use T1, T2. Some people use single letters like ABC or TUV. It's really whatever is most readable for you. Yeah. Yep. That really depends. Yeah. Okay, so now I've run it again. Not only do I not get an error, but I also get only the fields that I wanted, right? I get the product, quantity, product name, and price. And I think I'm going to rearrange these fields too, so that I have the product ID and the product name next to each other. So in order to do that, all I need to do is just change the order, and that's the order that it will be shown when I run it again. Boop, there we go. Easy peasy, lemon squeezy, indeed. Oh yeah, and that's a great question, Hertz. So even though I did the alias farther down, I can still use it up here in the select statement itself, because the way that the compiler actually reads this is different than the way you or I would read it. So the first thing it checks is actually to see where it's getting the data from. And in this case, so it's looking to say, oh, okay, I need to go to these locations to grab the stuff, and then I'm gonna and they want to alias these as T1 and T2. Yeah. And also, yeah, that's a good point. For now, T1 and T2 also help us remember what order we're joining these tables in together. Yep. And also, and before we go much farther, I'm actually going to do a quick edit here in the CSS for this page, because for some reason this sandbox doesn't let you make the SQL window any bigger, but we can do that because we know CSS, right? We know how to change the height of a box, right? We know how to change the height of a window, so we're going to do that. So I can go, it's right up here. Yeah. So you can do this too if you want to. You can go up, you can open the inspect window and find the div with a class of code mirror with all this junk after it. And you can change the height in the CSS from 140. I think I changed it to like 300 pixels, and that gives you a lot more breathing room. So I'll leave this up for a second. Hacking that CSS, indeed. Yes, we are major hacker mode today. Not only are we using SQL, we're using HTML and CSS all at once. Aren't we cool? Millie Maid, that's a great question. Do you always have to specify the table for each column, even if the column name is unique to one table? Technically, no. Because it will understand that it's unique and it will know exactly where it comes from and where to find it. However, I usually specify it anyway, and that's what my employer advises as well. Is just always specify. It's not going to hurt anything if you do, and it keeps things consistent. So you always know if you have 20 columns or 30 columns, you're always going to know the source that way. If you always specify, regardless of whether it's unique, you're always going to know which table it comes from if you specify. Yeah. So we can just do this, and we just added the CSS here to increase the size of our window so we can see better. Okay. All right, so this is a very simple join, but it helps us bring back the exact fields that we want to have. Now, let's actually start doing some manipulation on this, because this is all well and good. We have the ID, the name, the quantity, and the price. But what I remember, the original question that I'm asking here is, what is my biggest seller by volume, and what product is bringing in the most money, like revenue wise, right? And this is the price per unit. So that's it. So, you know, we got to think about that as well, and how we deliver this data set. Yeah. Yeah, and that's another good point there, Junathe. So if the table changes and another key is created, your request will still work if you specify, you know, the source of each field that you're bringing back. Nada, is it better to specify the exact columns that you want instead of using select star all the time? Well, that depends on what your data looks like. Generally, like I said earlier, what I do is if I'm starting with a table I'm unfamiliar with, I will generally do a select star for my first statement and just bring back everything and just see what's in the table. And then I usually always refine it down to just really the columns that I need, especially if I'm doing a join. It just keeps things more manageable that way. You really need to think about what results do you actually need. Yeah. But there's nothing wrong with, you know, using select star if you're just getting familiar with the data, seeing what fields are in the table, that kind of thing. And then you can refine it further as you go. And you can also do, so another thing you could potentially do is, if you're doing a join and you still do want everything, like all the columns from table 1, you can do t1.star, t1.wildcard, and that will bring back all the tables from t1, and then, you know, whatever tables you specify from t2. So that is an option. That's a thing you can do, and it will understand what that means. It'll say, bring me back everything from table 1, and then only those 2 fields from table 2. So if I run that, it'll work. See, it brings back everything from table 1, and I didn't have to list out all the columns. I just said t1.star, and then product name and price, which is the 2 fields that I wanted from table 2. So that's not what we're doing in this case. But yeah, that's a good question. Yeah, Linda mentioned it's more efficient. Yep. And some data systems charge you how much data you parse. That's true as well. Yep. Oh man, Sarada, thank you so much for the sub. That's much appreciated. I had some custom sub animations, and I don't know what happened to them. Like, they disappeared. I don't know why. But thank you anyway. Yes, much appreciated for the subscription. Okay, so yes, this is the basics of a join. But let's think about the actual, rerun this, there we go. Let's think about the actual calculation that we want to do here. So what I want to do is I want to get quantity and price, total quantity and total price for each product. So let's figure out how to do that. So I still want the product ID and the product name, but what I want to do is not list out each quantity individually. I want to add those quantities together, right? I want to add all the quantities together. So if I was writing JavaScript, what's a keyword that I might use if I want to add a bunch of stuff together? Obviously there's a plus sign, but that's good for like hard coding things. But what's a keyword that just says, hey, add a bunch of stuff together? Yes, reduces reduces. That's a valid answer. But in general, in plain English, we're just wanting to sum things, right? We just want to sum. Yeah, sum. That's all it is. It's a sum. And so being SQL, it's very plain English, right? So all we want to do is sum quantity, right? Cool. And we want to sum price. Okay, that's a good start. Um, we'll refine this a little bit more as we go, but this is a good start. So sum definitely works. And so it's going to understand sum, meaning that, hey, okay, I'm supposed to take everything in this quantity column and add it together in some sort of way, right? Okay, good start. And also too, usually if I'm performing some kind of a mathematical operation on a column, I don't want it to have the same name in my result sets. I want to be clear that I have modified this column in some way. So just like before, just like the way I aliased my tables before, I can also rename columns. So in this case, I'm going to rename this sum of the quantity as some quantity. That's very clear. That'll make it very clear that I have done something to this. So now in my result set, that column is now going to be called some quantity. And I'm going to do the same thing for price. I'm going to say some price. Yeah. So now that's what it's going to be called in my result set. Easy peasy lemon squeezy. All right. So we have the sum of the quantity, some price as some price. Perfect. But there's a little bit more that we have to do. Oh, welcome, Arshad. Yeah, so we're doing a basic overview of SQL here. Just very basic stuff, how to do select statements, how to do joins, how to do simple mathematical operations on columns in a, to return a result set. Yeah, that's basically what we're doing today. Not getting too deep into it, but you're welcome to stick around if you want to learn some of the basics of SQL. Welcome. Yeah, and actually, strictly speaking, the as keyword is not necessary. You could just say some quantity, sum of quantity, and then the keyword some quantity, the alias that you wanted to use. But I think it's much easier to follow if you just type as. That's very clear that you are renaming this column. Yep. Yeah. And so that's why I'm doing it in all cases here. But some SQL veterans might know that, yeah, why are you doing that? You don't need the as keyword. Well, it just makes it much easier to follow if I include it. So, all right. So we've summed this, and we've given it a label, an alias, and the rest of our query we can pretty much use this, leave the same, but we are going to have to add some additional information to the very end. Because if we think logically, I'm telling it to some quantity and price, but I'm not telling it how to do that sum. Basically, if I were to run this, SQL would be like, okay, you want me to add all this together, but like, what do you want me to what do you want me to subtotal it by? Nothing? Do you just want me to add all of the quantities together, like for the whole table? Do you want me to add all the prices together for the whole table? What do you want me to do? When what I really want is I want to see the total quantity for each product, right? Yeah, I want to see the quantity by product. That's my subtotal. That's how I want to subdivide this information. Yes. So some quantity as some quantity, but then I need to group my sums by certain information. Okay. So in this case, I want to group by the things that I am not summing. That'll give the compiler the knowledge that it needs to say, like, oh, okay, you want me to condense it down to this level and then do the sums based on that level of data. So I'm going to group by product ID and name. And then that will take it down to the level of product name and then do the sums at that level. Okay, let's run it and let's see what we get. Okay. 3 extra characters is a small price to pay for making much more human readable. Indeed. Sometimes, yeah. Sometimes you don't want to be as efficient as humanly possible. Sometimes you want it to be readable. Code Wars throwing hands over here. All right. Now let's look at what we got back. So we got back 77 records, down from like 500 and whatever, right? Because we're grouping things now. We're condensing it down and we're summing at the level that we specified. Yeah, do nothing. We'll get there in just a second, I promise. Yeah, I know that's the next step. So number of records is now 77. Why 77? Why do I now have 77 records? Where do we recognize that number from before? No, you're fine, Junathy. Don't worry about it. Good eye. Good catch. So excited. Yeah, hurts. Exactly. There's 77 products. We know that. We can see that from our product table here. We already know that we have 77 products. And since we're grouping we want to sum at the product level, that's the number that we would expect to see. Yeah. It's the number of products. Exactly. You all got it. You all got it. Yep. Yep. Okay. So we have the sum of the quantity here. And now we can see the count of essentially how many products have been sold of each product. So what would I do if I want to see, just as my first row here in my result set, what would I do if I wanted to see the product with the highest quantity sold? What do I need to do if I want to, almost said it, what do I want to do if I want to arrange my result set in such a way that the highest volume product is listed first? Yeah, we're gonna have to do a sort of some kind, right? Yep, and the specific syntax for that in SQL is using order by, and I'm going to want to order by some quantity, and yes, and you already said it. Yep, descending. Y'all are ahead of me. That's awesome. Okay, there we go. Okay, so we can see that the sum quantity highest amount sold is actually the Gorgonzola Tellina, which is a fantastic name. I love it. Okay, so we're gonna do one more thing and then we're gonna take a break, all right? And so somebody already spotted it earlier. Overall, our quantities are correct, but our prices are kind of funky. We didn't really check this before we ran it, but there's something wrong with the way that we're calculating. If I want the total amount of dollars that each of these products has brought in, there's something wrong with the way that I'm calculating price. Because if we looked at the product table, and I'm actually going to do that in another window here. I'm just going to select star from product really quickly. In the product table, it's listing out the price per unit. And so if it's listing out the price per unit. And so if I just join directly to, if I join directly to my order details table, and ignore the actual quantity sold and just do a straight sum, is that going to give me what I want? Is that going to give me the true total? If I just join to each row in the order table and ignore the actual quantity sold per order, is that going to give me what I want? So if I sold a quantity of if I sold a quantity of 5 of the same product and I join to the product table on like product ID, whatever, it's only going to give me the amount brought in as if I had sold 1 of those items. Yeah. So what I really need to do is I need to multiply the price times the quantity sold. I actually am already, you're correct saying, I actually am already grouping by that though. Yes, you're correct. We are grouping by the product. But what I really need to do to get the appropriate total is I need to multiply price times quantity sold. Yeah. And in this case, I need to multiply by the original field and not some quantity. I need to multiply by the price per unit. And so I'm multiplying by price per unit and the quantity per row. And then after I do that, I sum together and get the full result. And this is also showing that what we can do here is, so, and also this is a good point. So this calculation of price times quantity will be done for every single row in the order details table. So real quick, let's go back to order details and remind ourselves what that looks like. So for each order, I have a single product ID and then the quantity that was sold. So in this case, what we're doing is we're saying, all right, 12 items were sold in this order. I'm matching to the product ID and I'm getting the price per unit. So I sold 12 at a price of, say, like, I don't know, $5. And so for this row, what it's going to do is it's going to do 12 times 5 and get a result of 60. And it's going to do that for every single row. And then in the end, after it's done it for every single row, it's going to sum all of those together per product and get the appropriate total. So it's kind of an order of operations. And this is something that's kind of hard to wrap your head around at first, but you can check, you can check by doing some of the math manually. If you're not sure whether your join or your sum is working correctly, you can always do a quick manual calculation in Excel or in a calculator and see, like, look, is this summing in the right way? And after a while, you get the hang of the order in which SQL does things. So it's going to do row by row. It's going to take the price times the quantity sold. And then in the end, it's going to sum all of those together, group them by product, and give you the appropriate total. All right, so let's run this again. And we should see some of these prices change here. The count won't change, but the prices will. So, whoa, okay. Yes, that looks much better. Much higher dollar amounts now, which makes sense given these large quantities. Money, indeed. So before, where they may have sold, like 20 of these gorgonzola things in one order, we were only counting that price once. Now we're saying, all right, multiply 20 times the price and get the accurate total. Yeah. Okay. So this query is a little bit more involved. We're doing a join, right? We're doing a join. We're grabbing columns from both tables. And then we're even doing some manipulation on those columns, doing some simple math on both of those columns, subtotaling it at the appropriate level that we want to, and then ordering the results. And we can do all of that in one single query. We don't need to do it step by step. We can do it all at once. And then our result set that we get back is going to look exactly the way that we want it to. Yeah. So this was a lot. We're going to take a break. And so I might leave this up so you can look at it and maybe try it on your own. Try it yourself. Put it in the sandbox, or even try it on a different table. Try, doing a sum, or try doing another mathematical operator. You can use, you can do addition or division or any mathematical operator really on, any of these tables. Product ID 16. I should just filter on this, but price looks weird. Look at it. Should order by product ID. Oh, there we go. Yeah, so there's some I think the price maybe in the original table is like limited to X number of decimals, and it's just a decimal, it's just a rounding error. Yeah. Here's the link if you want to play around in the sandbox yourself. This is a really great sandbox for just testing out SQL queries. doing simple selects. And if you mess anything up, you have this magic button here where you can restore everything from scratch. But all we've done so far is just select statements. We haven't modified any data. So you won't need to use this button yet, unless you get a little ahead of yourself. I'm working as a SQL developer. I'm not actually a data scientist. I build the data sets that the analysts and the scientists and stuff use to do the things that they do. Yeah. That's way too expensive for a camembert. I know. I'm glad somebody knows their cheese prices, because I certainly don't. Well, the nice thing is that, Hertz, unless you were doing like actual like deletes or drops or anything like that, you shouldn't need this button yet. But maybe you were. I don't know what you've been doing. Oh, sorry, Roshan. Yeah, that was actually a consideration. If I go all the way down to the bottom here, there was, oh, it's not on here, but at some point I did read something about this sandbox, that it doesn't necessarily play nice with Firefox. And I apologize, I didn't mention that. If you're using Firefox, you may encounter weirdness with the way it functions. It does recommend that you use Edge or Chrome or Safari, or one of those browsers. Yeah, or Opera. I think Opera was one of the supported browsers. So I don't know why it doesn't like Firefox, but there you go. As a Firefox user, we're used to it. Oh, I'm sorry. I used to love Firefox. Yeah, not so much anymore, but yeah, it used to be my main browser. Okay, so I'll leave this up. We need a break, 5 minutes, and I will leave this on the screen. And just reset the timer so you can look at this and you can kind of puzzle your way through it, think about what it's doing, and then we'll do a little bit more when we get back. Firefox fell off. Okay. Yeah, it did. It really fell off in usage, didn't it? All right. Start. And there we go. All right, I'll see you back in 5. Okay, folks, come on back. Got about 30 seconds left, so mosey on back and I will catch up with chat. So Rada, so I think this is going to be, at least for now, I've really only planned on doing this as like a one-time thing, an intro to SQL, because the course that we're in, 100 Devs, really doesn't have a SQL focus. It's a MERN stack. It's a MERN stack type lesson plan. And so I don't want to focus too much on things that are not the focus of the course itself. However, we are doing SQL today just because it's on lots of job postings. And I think it's important to know a little bit of it and to be able to speak somewhat competently about it in a job interview. And then, give you a good, if you do want to learn more, I'm going to give you some resources at the end so that you can, do some self-study if you want to. Firefox. Okay. Never got this far. Why would you do any type of calculation or join in SQL when you can do it on your back end? And some folks answered, so Rascal had a good answer. The database is much better, faster, and optimized to do these things in nearly all cases. And that's true, yes. Anytime you put any kind of an application layer on top of a database, it's going to become slower, less efficient than just doing it directly in SQL, directly talking to the database. Yeah. And another thing, a lot of what I do in my job is building data sets that can be referenced repeatedly. So you're building these tables and things that people are going to be using and accessing via all different types of applications. So not just your backend, but anybody could build an application that references a table that I build. And so I build it directly in SQL with the calculation built in so that anybody can reference it without redoing the calculation, right? It's done, it's there. And so that data can be referenced over and over and over and over again. Yeah, and somebody else may have said that later. People talking about browser wars. Yeah, and D-Rocks essentially said the same thing. Yep. The nice part about the database is that queries can be coded to be reusable across the entire application. So the calculations are done in one spot and tested in one spot. Yep, absolutely. So in that way, you'll know that you won't have any differences in what that number looks like, depending on maybe issues with the code base or something like that. Hey, Hertz. Yeah, no worries. If you got to leave, that's totally fine. I am Sassy. We're going to go over some resources at the end of the presentation. If you have the link to the slides, if you need to like cut out or anything like that, you can skip ahead to like the second to last slide, I think. And I have a list of resources there that you can reference. Okay, so I think I see where you're coming from, Niashi. So, yeah, so think it, so the back end has the raw data, yes, but the back end has to be told to do that calculation. And a lot of times the way it's being told to do that calculation is via SQL. So you'll have SQL building out a view or building out that table and doing the calculation via a SQL query. So you pull data from a source, you do some calculations on it, and then you spit out a new table that has the calculation embedded in it. So the calculation still has to happen. It's just, it's happening behind the scenes and you don't see it. That's actually a big component of my job, is that I take data from a source, I do SQL calculations on it, and then I spit out a new source that has those calculations done and that people can reference. And they never know that the calculation is even happening. Pretty much a lot of what I do is very much behind the scenes. And so, yeah, that's just an example of how those calculations can happen database side without you even knowing that they've taken place. Let's see. Oh, we got to hydrate. Okay. I always wonder how it works in a real life example. For instance, when you have a product table with quantity and orders are placed, do you subtract any time a product is sold from the product table and the table is modified? Or do you run a query to know if a product is out of stock? A lot of times that stuff happens automatically. You'll have triggers that run, or you'll have certain like scheduled processes that run and do checks, and they tell you automatically. A lot of times this stuff isn't manual. You'll have like certain thresholds that are reached, and things that are, you can, the cool thing with databases is that you can automate a lot of the stuff that happens. So what I usually do in my job is I'll build like the initial structure of the thing that needs to happen, but I don't run that thing every single time. It's scheduled to run when something else happens. It's like a whole chain. It's a daisy chain of things that have to happen in sequence, or things that are triggered by other things. So yeah, very, very little of it is manual. Only the initial construction, you're telling it what to build. And then after that, it's pretty hands off. Yeah, databases can have min max. They can do pretty much any calculation, like any mathematical calculation that you can think of. Yep. A lot of that's built in. All those mathematical operations. Yeah. Yep, exactly. D-Rocks. I think you and I are thinking on the same lines there. Yep. You can have tables that maintain separate inventory counts. You can have, uh, yeah, the structure can become very complex to fit the needs of what you're trying to do. Which that's an advantage of using tables, because with tables, if you need, you can keep the original structure and not have to modify it at all. You can keep the original tables that have like the product descriptions and that kind of thing, um, and then just create a completely separate table that has additional information that you might need without having to touch the original structure at all. It's still there, it's still pristine, and it's still accurate. And then all you need to do is create a separate table that does additional things that you might need. And so that's one thing that I'm not entirely sure how that translates over to Mongo, because in Mongo, if you wanted to add like additional, fields or whatever, you would have to add it into each document and modify the structure of each document. And that's the thing that I'm not entirely, I don't grok that quite yet, because it's very different than the way I'm used to doing things. And that doesn't mean there's no way to do it, or that it's the wrong way to do things. I'm just not familiar with it yet. So the way that I've learned to do things makes sense to me, but there's always more to learn, right? Yeah. Reading Rascal's response here. Yeah, just it's in general, the way things are done is that, yeah, you have SQL queries doing base calculations that everyone is going to need, that basically make the base data formatted and calculated in the correct way, that's a common source for everyone, source of truth, as it were. And then any additional application specific calculations are done in the applications themselves. Okay, so we have done a left join that is allowing us to then basically turn information that was basically very transactional, right? It was just showing individual transactions and not really giving us any kind of big picture view, right? We were able to pull in additional fields from a separate table that we needed, that would help give us some visual context of like what products are these actual, like what products are we actually talking about here. And then we were able to do some simple mathematical operations to subtotal this data in a way that gave us some legit feedback about how well our products are selling and what type of revenue we're bringing in at the product level. Yeah. Yeah, D-Rocks, and that's kind of what I was mentioning earlier, as far as you can have triggers that fire, when things get added or removed, or when certain thresholds are reached. And those are trigger. What a trigger is it's essentially like a little program that executes automatically when something when its trigger happens, when whether that's inventory reaches zero for a particular product, whether that's product quantity passes a certain threshold, then you can trigger something else to happen automatically without you ever knowing. And maybe that's just sending an email. Maybe it's triggering a completely separate process to run, which does something else, like sends a restock request to a supplier. Yeah, the sky's the limit really on automation as far as database stuff is concerned. And yeah, and you can have scheduled queries that run at certain intervals, whether it's overnight or hourly, that do checks and maybe send status updates. Yeah. So trigger checks run after every table change? It depends. You can specify certain criteria to say like only trigger, only have this trigger run when product quantity, when the quantity of a product is zero. I mean, it's really customizable. Um, Interesting trigger story. So the thing about triggers is that they will run when their criteria is met, no matter what else is happening. So at a previous job, I was not a developer at the time, but I was working closely with developers, and a developer built a trigger that was unfinished. So it was supposed to change some data, but it didn't have the appropriate filters and it didn't have the appropriate safeguards. And it was supposed to basically run whenever a certain field was changed, and this field changed a lot. And so the developer accidentally released this trigger into production before it was finished, before it had the appropriate criteria. And so that trigger started doing what triggers do. And every time that field changed, it fired and it started editing data. And I was working in a production environment, so the database changed a lot. And so this trigger fired a lot. It was firing hundreds of times a minute and changing data. And the developer, who had gone to lunch, did not know that they had accidentally released their trigger into a live production environment. And we did not know anything that was happening until the actual operators, like the machine operators down on the production floor, started saying that their machines weren't working anymore. They weren't, because they weren't getting any data from the database because it was actively being destroyed. So yeah, so this trigger was firing and changing data just like it was told to do, and with zero safeguards. And so yeah, most of the database was destroyed. Um, Yep, that was an interesting 48 hours or so. And there were no adequate backups. So that's another thing. This restore database button up here. This is sort of an analogy for what you should be doing in real life, which is creating regular backups of your database. And if the worst were to happen, you should just be able to restore to a very recent point in your data and bring things back to normal. Well, in our case, we did not have that. So an outside consultants had to be hired at an exorbitant rate of money and to try to bring things back to normal. And in the end, much of the data was able to be restored, but not all of it. And so some data was still lost. And that developer never released into production again. They were not fired, because that's not an appropriate way to, when somebody makes a mistake, it's just a really expensive training opportunity, right? So that developer, of course, never made that mistake again. But yeah, that was really interesting. Exactly. Rascal, yep. Rascal summed it up really nicely. The computer will do what you tell it to do. And so in this case, it was told to change data, so that's what it did. It didn't care what the consequences were because it's just doing what you told it to do. Yeah. And so I bring that up because that's, as we get more into actually modifying data using some SQL, it needs to be a consideration, is that the computer will do what you tell it to do, whether that action makes sense or not. Yeah. That's always a consideration, especially with SQL when you're dealing directly with the database. You're really talking directly to it with no middleman, no program looking over your shoulder. You're just talking directly to the database and telling it to do stuff. So The dev is now cast in concrete, like Han Solo and Carbonite. Yeah. Indeed. Trigger warning, yes. Yes, it was an expensive lesson, Rascal, indeed. And that dev was actually, it actually still is one of my very good friends. And so we always called him, after that, we always called him Butterfly Guy because his trigger was like the butterfly wings that, you know, caused a tornado, you know, on the other continent. So yeah, we called him Butterfly Guy. Yeah, I do use Oracle at work. Yep, PL SQL. Yeah, I know that Oracle is not often people's, you know, go to favorite SQL solution, but I work for a major university. If that tells you anything, kind of how they roll. I have to install a DBC for users all the time. Yeah. Okay, so yes, we've done a join, and but what we've done so far is a left join, right? We wanted to keep all the records in our original table, and we wanted to, you know, keep all the records in the original table and return matches from the product table if such matches exist. So what's the other type of join that we talked about? We did a left join. What's the other type? I know we talked about a couple of additional types, but what were the two that I said we were going to focus on? What's the other one? No, not full outer join. No. Inner join. Yes. Right. That was so I said we were going to focus on two. Um, we did left join already, and the other one we're going to talk about is the inner join. Yes. And what does the inner join do? Anybody remember? Pop quiz. I didn't say I was going to pop quiz you, but here we are. What does the inner join do? What do you remember? Yeah, it gives back only common. Yep, only common matches between both tables. Okay, so let's figure out how we can demonstrate that. So um, I'm gonna back up a little bit in our sort of you all everybody here, yeah, everybody has the right answer. Awesome job. Way to remember. I know we just talked about that, so wasn't sure how many folks were gonna get it, but y'all got it. Yes. All right, so let's back up a little bit in our query, and we're gonna kind of simplify things back down again. So let's take out the group by and the we don't have to take out the order by, but let's take out the group by. We'll go ahead and take out the order by as well, and let's get rid of the mathematical calculations. We're just gonna go back to a number that we recognize as far as our row count. So we're just gonna go back to these four fields. So just we're going to have product ID, name, quantity, price, and the table we're selecting from, the join that we're doing, and the field that we're joining on. So back to basic join syntax, no calculations. And the reason I'm doing this is I want to get back to a record count that will just visually recognize it. Yeah. Oh, Green Jenny coming at it with the statistics notation. That's rad. Nice. Yeah. Oh, missing comma on line 4. Thank you. Yep, it would have given me an error if I tried to run it without the comma. So, yep, good catch there. All right, let's run it. Okay, so now we're back to, we have our 518 records, which is the total number of records in our order details table. Because order details is our table 1, right? If we're doing a left join, order detail, all the rows from order detail are going to be preserved, and then the match, you know, T2, which is our product table, that's going to be brought in, and it's going to, you know, match against that. So let's run this and change. All I need to do is change the notation from left join to inner join. So I just changed the word. That's all I need to do. I literally changed the word left to the word inner, and now let's run it again and see what we get. Okay, I ran it again. It did run. My record count is still 518. Why do you think that is? Why do you think my record count didn't change at all? Any thoughts? I changed my join type from left join to inner join. So now it's looking for, it's only going to return matches from both tables. But still, when I ran it, my record count didn't change. Why is that? Yes, exactly. Yes. So a match exists for product ID in all cases in both tables. So for every row in this order, in this order details table, for all 518 rows, this product ID had an exact match in the product table. So a record was returned. So it said, all right, you're good to display in the results set. I got you. Yep, good to go. I'm going to display you. Exactly. Every order has a product. A matching product in the product table, indeed. Yep. Y'all are catching on to this. I dig it. All right. But what if that wasn't the case? What if that wasn't the case? So I'm going to just copy this query. I'm going to drop it into a notepad so I have it, and we're going to run it again. So if you're following along with me, I would suggest that you do the same. Copy this, put it on a sticky note, or I don't know, somewhere else in a Word doc or notepad. And I'm going to do something really quickly. I'm going to just write a very simple statement here that is going to delete a row from the product table. You don't have to memorize this yet. We're going to touch on it again in a little bit. I just want to demonstrate what inner join actually means. So I'm going to pick a product ID here. This one looks really funny. I'm gonna get rid of it. Right. Do it. Okay, rows affected 1. All right. So what I just did there is I deleted a row from the product table. So now there is no longer a product with an ID of 77. So I'm going to go back to my inner join, and I'm going to run it again. And let's watch that record count. So we can see that the products table over here now has a record count of 76, where it used to have a record count of 77. My order details table used to have a record count of 518, but let's see how many records we get back now. I keep wanting to hit F8, which is the quick execute button in PL SQL, but I gotta click the stupid button. All right. Okay. Now I only get back 510 records. That's because there are 8 records that were associated with the product that I deleted. So now my query runs and it says, all right, I'm going to select from order details. I'm going to inner join products and look for matches on product ID. Whenever it gets to a row with a product ID of 77, it doesn't find a match. And so it discards it. Yeah. Any row with this product ID won't return. Exactly. It won't be shown. Now, that's all well and good, but let's say that's not what I want. I still want to show all 518 rows in my query. So if I switch this back to a left join, let's see what happens when I encounter one of the rows that associates with that product ID of 77 that I deleted. What do you think will happen? Now I'm changing it back to a left join, and I'm going to run it again. What will happen when I encounter a row with a product ID of 77? What will be shown on the under the product name? You think, okay, so the guess is that it will return the same. Yeah, yeah, no name. Okay, so there's a couple guesses out there. Let's see it. All right, and I'm going to also I'm going to add an order by here, so it's a little easier to see. Order order by T1.product ID descending. This will make it easier to see. All right, see that? Okay, so now since the left join, we're back up to 518 records. But look at that. Yeah. So anytime it encountered a product that no longer existed, because it's a left join, it still kept the product ID, but any fields it could no longer find are now simply marked as null. Yep. So that illustrates the difference between a left join and an inner join, right? The inner join just collapsed it down and got rid of those rows entirely. Didn't even show them at all. But the left join kept the rows and marked the missing fields with null. And you can, somebody asked, can you XOR the query to find the missing products? Yeah, so what you can add an OR. So we can add a where clause. It's the same number of results. Yep, because it's a left join. We changed it from inner to left because we wanted the original count. But yeah, you can add a where clause here. Where, and you can say something like where product, what is it? T2 dot product, cannot spell now. Product name. Now, I don't know if this will work. It works in PL SQL, but let's try it. You can sometimes say where like something is null. Let's see if this works. Okay, yeah, there we go. It works. Cool. Yep, so in this case, I said where product name is null, and that returns only the rows that are null. Yeah. Oh, thank you, Madeline. I'm glad you enjoyed the walkthrough of the CRUD app. That's awesome. Yeah, I've done several other videos on CRUD, constructing CRUD apps. So yeah, feel free to catch those as well. I've 3 or 4 of them now. Yep. And so in this case, we said product name is null because instead of product ID, right? Because if I did product ID null, that wouldn't bring back any results at all because I'm getting the product ID from table 1. So it's important to remember the source when you're trying to do these filters. The source table, in this case, is T1. So I need to, if I want to grab the null fields, I need to focus on table 2, which has the missing row. Yeah, so that brings back the proper null records. Good question. To match the Venn diagram that was on the slides. Okay, let's look. We'll go back to that real quick and look. All right. So our joins are inner join, which we did, right? Returning matches from both. And our left join, which returns all rows from table 1 and only the matching rows from table 2. The right join, which essentially does the same thing except reversed. And then the full outer join, which returns all records from both tables. Oh, T2.product ID is null. Yeah, you could do that. Yeah. And I mean, that's what I would do if I was looking for missing records in, in whatever case. I would just go, and say, all right, look, I think I want to figure out which fields are null in my second table, or which fields are null. If I'm doing a left join and I'm not sure if I have any null records, I would probably look for null values like this. The only time, Thorium, the only time that I've opted for a Cartesian join has been by mistake, and then I got yelled at. So, I mean, I think there are cases where it does make sense. If you have two data sets that have some commonalities, but then you know that they have unmatched fields in both, and both of those fields are important. Like all the data is important in both data sets, and you don't want to exclude any of it. That's a case where you would do a Cartesian join. It's not as common, because theoretically, I think your data should be cleaner than that. But I mean, that's not always the case. That's why it exists. But really, the only time I've done it is by accident. Yeah, and GreenGen, it can be useful for reporting on dates. I suppose if you had two different tables with different date ranges and you wanted to synchronize those together. Oh, and that's a good point, Linda. So yeah, the way we say equals null is slightly different in SQL. So um, we don't just say equals or not equals like this. Um, in the case of null, you need to say is or is not. Yeah. So it's written out in that way. Not entirely sure why. That's kind of just how it is. Um, Leibniz, so intersect, difference, and union. Yeah, I mean um, those are the like statistical terms, right? But I think it's easier to understand and easier to absorb if we just use the terminology that we're actually going to be putting into our code. In which case it's inner, left, right, and full outer. But yeah, I mean statistics does have similar terms, right? Terms that illustrate similar concepts. But SQL, it's like most programming languages, has its own terminology for things. Yeah, null is not technically a value. That's right. So it has slightly different wording. Yep. Okay. So let's see. That's an inner join versus a left join. Does anybody have any questions on those two things before we move on to actually modifying tables to actually performing data manipulation on tables themselves? So not just getting results, but actually going back and saying, I want to actually edit these tables rather than bringing back a result set. Oh, thank you, Niyashi. Good night. Have a great night. Any questions on, and like I said, we're only doing left join and inner join. You're welcome to explore the other joins. Actually, I don't even think this sandbox allows you to do right joins for some reason. I don't know why. But like I say, left and inner are going to be the two most common join types that you will encounter. You should be able to speak to right join and full outer at like verbally to like say what they do and understand what they do. But at least in the US, I mean, somebody said the EU might be a little bit different. But at least in the US, left and inner are the most common. Yeah, and full outers they're very rarely supported in most implementations because they're not good. They use a lot of resources. They often result in massive data sets returned. They're just wild. Yeah, you had to do a left join an interview. Yeah, absolutely. I am not surprised. That is, like I say, that's the bread and butter. Very common. So yeah, you should know how to do that. Well, and Silva, like kind of like we talked about before, where the calculations are performed depends on the implementation. So if it's a calculation that is going to be referenced by like tons of other apps, so thinking about like an e-commerce facility, right? You might have a backend that's handling. You might have a logistics area that's handling like orders. Then you might have a customer facing point of sale area that's handling customer orders, and then you might have like a production area that's actually producing this stuff. And so if that calculation is relevant to all of those different areas, for like I'm thinking like inventory, then that calculation is probably going to be performed on the database side just because it's going to be referenced by a bunch of different areas. However, if the calculation is something like count of customer complaints or something like that, then it might be app specific to like the customer facing departments. So where the calculation is performed really depends on how widespread the reference needs to be. So it really depends. In general, for more efficient calculations, the closer to the database that those calculations occur, the more efficient they'll be. The more layers of abstraction you add at scale, at large scale, at massive numbers of transactions, the more abstraction you add, the less efficient things become in general. Yeah, great questions. I like it. Okay, so let's go ahead and go back to the slides. We've got a few more things to cover. So we got to joins before, and we did our examples. So we practiced left join and inner joins. Now, the next thing we're going to talk about is modifying tables. All right, so SQL does allow us to not only read results using select statements, but we can also actually modify the existing data in tables. And it allows us to do this directly rather than just writing queries to read it. So insert, as you might expect, insert adds a new row to the table specifying the values for each field in the row. Update updates an existing row based on criteria in a where statement. So similar to our select statement, you can update multiple rows at once, saying, update, customer, update, customer status to yes, where account balance is 0, right? That would update all the customers, setting a paid field to yes, where if their account balance is 0, meaning that they've paid their bill, right? And you could update 100,000 records all at once with a single statement, which is really powerful, right? And delete does something similar. Delete deletes an existing row or rows based on criteria in a where statement. So, thinking about this a little bit, what problem could you foresee when you're using update and delete statements? How could these statements be dangerous? What might happen if you use these statements incorrectly? Yeah, Edward, and that's a good point. This slide does look a little crud-y, right? These terms should be similar because it's the same type of thing that we've done in MongoDB, just a different method to do it. Yeah, and the way to prevent it is doing it inside of a transaction. But yeah. So yep, that's a good point. It's not revertible. You can't roll it back if you don't have it inside of a transaction. Yeah. Yeah, Aaron nailed it, and so did AZZZ. Yep. So a couple folks caught it. What happens if I run, let's say, a delete statement, but I don't have a where clause? What do you think will happen? Yeah, and Aaron mentioned it. Yep. Yeah, and Sane mentioned too, if we run an update statement with no condition, then SQL's like, I can update all the rows for you because you didn't say what you wanted to update, so I'm just going to do it all. Yep, delete all the things, indeed. And that's kind of what this GRU meme is referencing here. So write update in SQL for one row, double check it's right, and run it. 4 million rows affected. And yeah, that's I think that's something that many SQL developers fear. Is accidentally running some kind of modification statement, whether it's an update or a delete, and forgetting the where clause or accidentally running it without the where clause in place. And yeah, then you screw yourself. And so I've never actually ruined data in production by doing this. But I came close one time. So there was one time I was working for this e-commerce facility, writing very simple SQL statements, but occasionally I would need to update things. So I would do like a update statement here and there for like updating an order status. If for some reason it didn't trigger properly in the system, I would update the status to shipped, or I would update the status to in process or something like that if there was an error and it didn't happen automatically. So there was one time I was like, do, update order status to shipped, and I got distracted or something, and I didn't write the where clause. And I executed it. But the good thing is that it was actually so many rows in the table that it only finished reading the rows before I figured out what I had done. Like I saw it was like reading at the bottom of my Microsoft SQL Server like compile window. It showed how many rows were being read, and I was like, and it was something like this. It was like 40 million rows or something like that. And I was like, wait, no. And so I stopped it. And luckily the way that, the way these transactions work is that it reads all the data first and then updates. And so nothing actually got updated, but that was this, I think I sweated through my t-shirt because it was just, that would have really, really screwed things up. So yeah, you can do a lot of damage very quickly with a simple SQL statement. And so that's why I just want you to be aware of what types of things that can happen. And we'll demonstrate a little bit of that. We'll have a little fun and we'll break some stuff in our little sandbox here in a minute. Yeah. Yeah, AZZZ. So Redgate actually does, you're correct. And I love Redgate for that. Redgate is a kind of a SQL helper. It helps you with like autocomplete things and do complex operations pretty simply in SQL. And that was before I actually had Redgate. After I got Redgate, yeah, it definitely gives you that extra little barrier to screwing things up royally. So you always back up things before you do it or live dangerous. Well, I mean, no, I personally, when I'm doing SQL now, at least, I'm always doing it. I'm always doing any testing in a non-production environment. So inside of like a QA or a dev environment, there's actually several layers of that before my code ever even reaches the eyes of an actual end user. So any good employer should have multiple sandbox environments for you to test in. And if you do screw things up, it can just be restored from the production environment, and it's pretty quick to do. That employer that I was at where I almost screwed things up, that they were not necessarily the most robust employer, and they did not have the appropriate environments. But most employers will. They'll have sandboxes, dev, QA, places you can test where if you do make a mistake, you're not gonna, kill the system. So Rascal says, I've been able to cancel a process before it's completed terrible stuff before. Free adrenaline rush should totally be a sport. Yes, I agree, Rascal. I think my adrenaline was through the roof for like half the day after that. Yeah, absolutely. Thanks, Rascal, for sharing the slides and welcome to you and Dude. Or just use read-only databases. Yeah, that's a great point. Databases can be made read-only for certain users. You can set permissions for that type of thing. So in that case, it would only allow you to run select statements. You could still read the data. You just wouldn't be able to edit it in any way. And that's a lot of times that's a real important component of database access control is just who gets to, number one, access the data. And then number two, who gets to actually write to the database versus just reading from it. Yeah, and databases have redundancy. They have multiple environments. So you can, if one environment gets corrupted, you can simply restore from, like the production environment down to a dev environment if that dev environment gets corrupted. Yep. Oh, man. You've had to replay the transaction log to undo your stupidity. Yeah. Yeah, and there's ways you can get around that. We're not going to touch on that, but there's ways that you can enclose things in like a transaction. So you execute it, it makes the change locally without like pushing it up to the real database, it still shows you the results, but they're only visible to you. And you actually need to hit a separate button before that change gets committed to the actual real live database. And that can be really helpful. Except when you forget to hit commit and then you wonder why your change isn't showing up. And I've done that, many times. Like, did you commit? Oh yeah, crap, I didn't commit. But it's still, it's a good safeguard to prevent you from making mistakes. But yeah, but you can, it's the main goal of this is that you can edit the data directly. You need to be careful when doing so. And most employers are going to have safeguards, safety rails, that kind of thing. But it is important to know that damage can be done if you are not careful. So let's do some damage, shall we? All right. Let's go back to our sandbox. Green Jenny, or use a system where two programmers have to simultaneously turn their commit keys to execute a transaction, like a missile launch. Yeah, that'd be cool. Like a manual key, just like. Okay, we'll go back to our sandbox here. And let's go ahead and restore the database. I know we only made one change so far to the product table, but let's restore just to put things back on an even keel. So I'm going to click the button. And it will say, it'll restore the database. Are you sure you want to continue? Yes, I do. Boop, restored. Everything's back to normal. We are back to square one. I have a friend, she was the DB admin and she forgot to do the backup and lost 1 month of transactions. She was fired. Oh my goodness. Wow. Yeah. Whew. That's rough. Yeah, backups are so important. Okay, so let's start by doing an insert statement. So we're gonna look at a different table for this. We're gonna look at the customers table for this. So first off, as with always, when looking at a new table, what I generally always start with is just what it's done here. I start with a select statement and just select star and see what's in here. All right, so what do we have in here? We have a customer ID, which is what? What's our customer ID in this case? What do we call this field? Execute your SQL, sir. What do we call the customer ID field in this table? It's a unique identifier. Yeah, right. It's the primary key. It's the unique identifier that if we wanted to join to this table, we could, right? And we could join on this customer ID field. Yes, it's the primary key unique identifier. Okay, and we also have the customer name. We have the contact name, address, city, postal code, and country. Yep. All right, so if I wanted to insert, let's say I want to insert a new customer into this customer table. So the syntax that I'm going to use is going to start with the word insert. That makes sense, right? And I'm also going to say I want to insert into customers. Makes sense, right? I say I want to insert, I tell it what table I want to put stuff into. And if I'm writing an insert statement, the next thing I need to specify is the specific columns that I want to insert. So in this case, I'm going to just go ahead and make an entry that's going to cover all of the columns. So insert into customers. I'm going to have a customer ID, a customer name, a contact name, an address, a city, a postal code, and a country. Okay, so this is saying, hey, I'm going to be inserting values into every single one of these columns. So there's going to be a value associated with every single one of these columns. So get ready. All right. And then I say values. And here is where I specify the specific values that I want to insert. So in this case, I'm going to have a customer ID, and this customer ID should be unique. I'm just going to use one that I know will work, which is 100. Remember, because it needs to be a unique identifier, it is the primary key. So customer ID 100, customer name is going to be, what is the name? I had a name I wanted to use. Hang on. See. Customer name. Oh yeah, customer name is the name of like the business. So it's gonna be Lumen Industries. And this needs to be a string. Lumen Industries. The contact name is going to be Harmony Cobell. And then the address will just be something like 123 Electric Drive. So you all get the gist of what I'm doing here, I think. Each time I insert a new row, I need to specify the values for each row that I'm inserting. So it's a little time consuming, right? A lot of the times when I'm doing mass inserts, I'll usually actually just do it in, if I don't have any kind of program that can do it for me, I'll build the code in Excel and do it formulaically. So I'll build out each insert statement as a formula and put in all the values that way in mass. But for a single insert, it's not too bad. All right. And with this, each of the values that I'm inserting lines up with the order of the columns that I've specified here, right? So each one matches each column. Each value matches each column. Okay. Yeah, Linda, I can share with you at some point how to do that, how to build mass insert statements in Excel. Yeah, it's not too bad at all. All right, let's run it and let's see what happens. All right, so it says rows affected 1, which makes sense because I have inserted a single row, right? So now I'm going to run the customer table again, and let's see what it looks like. So I should have done an order by, but here we go. All right, so now if I scroll down all the way down, I can see that I have this new row in here with all the information that I specified, and everything is in the appropriate columns. Great. Okay. So that's fantastic. I've put in this additional customer here, but as I'm scrolling through, I noticed that I specified the country here to be United States. However, in other cases, it's listed as USA. So I have a bit of a data mismatch here. And so if I came back later and I tried to do a query, select star from customers where country equals USA, I would miss out on this row here, right? Because it doesn't match. So I have a data integrity problem. And so I need to fix that. So what type of a statement would I use? Let's go back to our little list of various ways we can modify a table. What type of statement would I need in order to fix this mismatch between the countries? Yeah, I mean, in general, yeah, the address information should probably realistically be its own table, but in our little fantasy land here, what would I do? Yeah, we do an update, right? We'll do an update. Yes, exactly. So we're going to do our update, then we'll take a break. And then we don't really have all that much more to go. When we get back from our break, what we'll do, so I'm going to do this one update. And then when we get back from our break, we're going to have some fun with breaking things. I'm going to show you how to break things after break. So the things you should not do. Yes. Because I can. All right. So I want to change this row that I just inserted. I want to update it, which is correct. I want to update it to have the correct country that matches the other countries that we already have. So update customers set, now, when I say set, here's where oops, sorry, that's wrong. When I say set, I need to specify the specific column that I want to change. So in this case, the column that I want to update is country. Set country. I'm going to set it to USA to match the other columns. Now, I also need a where clause here. So I make sure that it only targets the row that I want it to target. So what's a way that I could specify my update statement to only target that specific row that I just inserted? What's a way that I could do that? Yep. Yeah, there's multiple right answers to this question. In this case, I know exactly what the problem is, and I know where that problem is. I know for 100% of a fact that this issue only exists on the single row that I just inserted, right? So I could say where customer ID equals 100, right? And that would work. If this issue, this data integrity problem was affecting multiple rows, let's say I inserted like 5 rows before I figured it out, I could say where country equals United States, and that would target all 5 of those rows simultaneously and update them all. So if I run this right now, we'll see it'll only touch 1 row. But just knowing that those are the difference. We can target a single row, or we could target all affected rows potentially, should they exist. Yeah. Andrew, that's a good question. So they asked, would, the double equals like we use in JavaScript, or like is, would that work? No. In this case, we're dealing with real values here, and in SQL, we use the single equal sign. And for values, you have to use equals if you want it to do an equals operation, I guess. So yeah, let's do this. So we can see that the number of rows affected was 1, just as we expected. But again, if there had been 5 rows where the country was United States, you would see a 5 here. And so that's, you can update things extremely quickly, and it's really, really powerful, but it's also really dangerous, as you might imagine. Yeah. Yeah, and there is the like keyword, which we touched on a little bit briefly earlier. You can use like in like update statements as well. You could use like. I tend to try to avoid using like in an update statement, just because there's so many ways it could go disastrously wrong if your data is not structured in the way that you expect. Yeah. Hyper Essie, I'm flattered. No, I don't work for NASA. I just have a kick-ass NASA t-shirt. But I appreciate it. Okay, so let's take a break, and when we get back, we're gonna break stuff. So stay tuned. We're gonna blow some stuff up when we get back. So I'm gonna show you how things can go wrong. All right, because that's fun and I want to do it. So where did my timer go? I think I lost my timer. Break, then fun SQL. Indeed, that's the goal. All right. Oops. Yeah. Reset. And I'm going to zoom out again. Boop. Full screen and start. There we go. Okay, I'll see you back in 5. When we get back, let's cause some havoc. All right, come on back, folks. We got about 45 seconds left in the break. And we still need to talk about how to do a delete statement correctly, and then I'll show you how to do it wrong. All right. All right, I'm going to stop the timer and turn my webcam back on. Hello again. Okay. So the last thing we did was we did an update statement, and we set the country to USA, where the country currently equals United States. And I can do the reverse now. So I could set the country equals United States, where country is USA. So let's just do that really quickly and show, so now every single country in our table should be set to USA. But let's say, sometimes you're in the middle of a project, and there's a scope creep or a requirement change, and the business side says, actually, no, we don't know what we were talking about. We actually need it to be different for regulation reasons or tax reasons, right? And you're like, okay, fine. I'm going to rename all the fields in this table, so I don't have to do them individually. I can do them en masse by simply saying something like this: set country equals United States, where country equals USA. So previously, when we made changes to the database, we only affected one row, right? Now let's see what happens if I run this update statement, knowing that every single customer with a country of United States should be affected. So run this. Okay, so now I've actually updated 14 rows. So let's go ahead and do a quick select on customers and just see what that looks like. So now I shouldn't see any. Yeah, so we can see that there's United States here. And yeah, there's more United States. Okay, so every single row that was previously USA has been updated to say United States. Right, so what that tells us is that we can update multiple rows simultaneously with one single statement. Awesome, right? Okay, what happens if I'm just being I'm super tired, I'm moving quickly, update, it's like 2 a.m. for some reason and I'm still working. That doesn't really happen with me, but update customers, and I'm thinking, okay, I need to set the country to the United States. That's what the the project requirements are like that. Got a deadline. Okay, fine. Update customers. Set country equals United States. Okay, good. All right, done. Run. Uh-oh. Uh-oh. Whoops. All right, let's query the customers table and see what we did. Oh no. Oh no. Everyone, USA, USA, USA. You all live in the United States, whether you want to or not. Yep, everything is United States now. And it was very easy to do, right? That was a one-line statement. That was a one-line statement, and I affected every single customer record. Now imagine doing that for 200,000 records or 1,000,000 records. It would be the same statement. You could do it just as easy, but there you go. Is there a one-line undo? Yes, I mean there is. You can do. Generally, when you're doing big changes like this, you would want to enclose things inside of what we call a transaction. Like I mentioned earlier, what that does is it makes the change for you, but it only makes it locally in your instance of like in your session or whatever, and it shows you how what the change would do, but it doesn't actually write it permanently to the database until you click a separate button saying, yes, this is what I want, please write it to the database. So that's really what you should be doing when you write these types of, big update statements. But that's, we're out here to break things today. So yes, so that was a one-liner that effectively ruined a table, right? So very easy to do. And let's talk about the Mac Daddy, which is delete. So delete is the last thing we're going to talk about today. SQL woke up and shows violence. Yes. SQL is the best way. It's the most efficient way to make large scale changes to a database, right? We talked about how efficient it is to use SQL to talk directly to the database. And it's very easy to read and it's very easy to write. But I said there were drawbacks to that, right? Earlier I said there's drawbacks to this. And that's one of the drawbacks, is that it's also very easy to screw things up. So I just want you to be aware of the type of damage that you can do if you're not careful. So, but let's talk about deletes. So let's do deletes. So in the case of delete, it's very similar to some of the other statements that we've written, except how delete works is it works on a row by row basis. Okay, so instead of saying delete, customer ID, customer name, etc., I just say delete from customers and then where. So it's going to work on a row by row basis and delete whole rows at a time. So if I just wanted to maybe like nullify a certain field inside of an existing row, I would probably use an update statement for that. I would say, update customers set address equals null where, and then have my criteria, right? I could do that. I could do that sort of fine-tune adjustment using an update statement. Whereas if I just want to go in there and blitz some data, I'm going to use a delete. To catch up with chat here a little bit. All right. Folks want a SQL series. Oh man, maybe I really want class to catch up to SQL a little bit before I do that. But maybe we'll talk more about this, in the future. Back when I was in the nuclear Navy, we weren't allowed to learn by crashing things. I like this way of learning through bad practices so much better. Yeah, it's fun, isn't it? Sometimes it's fun to just ruin things and see what happens, so that way you never do it in real life. Congratulations, you're being annexed. Okay, so we're going to delete from customers where, let's delete that one row that I inserted a little bit earlier. So we'll delete from customers where customer ID equals 100. Okay, and remember customer ID 100, this was the row that we put in earlier, right? So we currently have 92 records in the table. So I expect it to go down to 91 when I execute this statement. So, boop. All right, it says you made changes to the database. Rows affected is 1 as expected because we were careful in constructing our where statement. And so now if I query customers again, we can see that we have 91 records and the entire row that I inserted earlier is gone. Remember, deletes work on a row by row basis versus a lot of the other stuff that we've done where you're manipulating individual columns or fields inside of those columns. Yeah. So just something to be aware of. All right, so now so delete from customers where you can also structure your delete statements a little bit differently. You could say delete from customers where customer, if you're not careful, you could say delete from maybe you meant to say where customer ID equals 50, but instead you say where customer ID is less than 50. You just have a little fat finger, a little mistype. Let's see what happens. Oh, rows affected 49. Fun stuff. All right, now my customer table has gone from 91 records, or I think it was 91 before. Yeah, it was 91. Now it's down to 42 records. And it has, without question, deleted every single customer ID below 50. So, yes. Yes, so that was how a bad where clause can very quickly ruin your data. Now, again, similarly, let's see what happens if I don't have a where clause at all. Now, some programs like PL SQL Developer and some code editors will allow you to execute components of a SQL statement individually. So if I was doing a select statement and I had a where clause on it, but I didn't want to run that where clause, I just wanted to see like the whole data set for just a minute, I could highlight the portion that I wanted to execute and just execute that portion without running the rest of it. That could be really dangerous when you're working with update statements or delete statements, because you could inadvertently just select this part of your delete statement, run it, and royally screw things up, even though you did have a where clause, you just didn't run it. So I don't think this editor allows you to do that, but so I'm just going to delete the where clause and we'll run that. All right, delete from customers. Boop. Now customer table is empty. So if I run it, it literally says no result. We have essentially truncated the customer table entirely. So again, very powerful, very dangerous. With great power comes great responsibility. Yes, bye customers indeed. And so think about that. The way that tables are all related to each other. You might have queries that are joining tables together and then building additional tables based on those joins. You might have views and reporting views and all sorts of layers that are built on top of your base tables. So if one of them gets damaged, one of your base tables get damaged, it can have ripple effects, which can affect the entire organization at large. So something to think about when you're working directly with tables is be careful. Yeah, it's running directly in browser, and each visitor gets a local instance of the database, which I think is really cool. Delete mine from this job. Yeah. Yeah. Theoretically, your employer should have a very robust and lovely sandbox testing environment if they're a good employer. So you shouldn't, hopefully this type of thing doesn't happen in production, but just saying. That's the kind of thing that can happen. So feel free, mess around with this database and do this stuff. Break things, move fast and break things in this database. This is why I'm sharing it with you, just because I think it's super cool. It's fun to test. I would say if you're going to practice anything, practice select statements. Select statements and joins. Do select statement after select statement in all different ways. Try things. Do order by, do group by. Try mathematical operations on columns, alias columns, do left joins and inner joins, practice stitching data together and see what happens when you try different combinations. Those are the types of things that the majority of people are going to need to know when they're working with SQL, is how to write a good select statement that returns exactly the data that you want in the format that you want it. So if you're going to practice anything, updates and deletes and that kind of thing are fun, but really get your selects down so that you could just code one out in an interview just like that, or even whiteboard one, so that you could, if you're asked in an interview, hey, can you whiteboard me a quick select statement with a left join? You could be like, yeah, I can, and you just write it right out. So get good at those out of anything. Yeah, Zarkov. So we did. You may have missed that. We did that before. I think, did we do that before break or right after? But yeah, we did do an update. If you do an update statement without a where clause, it will just run the update on every single field in the database. Yeah, it doesn't care. It'll just blitz it. Yep, it's a good question. Yes, it will update everything. So the way SQL works is the computer will do what you tell it to do, right? And so if you don't give it a filter criteria, it's going to be like, all right, you wanted to update everything or you wanted to delete everything. Let's go. Let's do it, baby. And it will. Yeah, and I'm going to give you all some resources. We got a few more slides. We're going to go back to the slides for just a little bit. I've got a few more slides, and I'm going to give you some resources at the end of the slide deck. Okay? All right, so let's go back. Any more questions on updates or deletes before we go back to the slides? And remember, if you're working with this database, you can always just restore, and it'll put everything back to the way it was. No harm done, which I think is fantastic. That's why I really like this sandbox. Because you don't, a lot of sandboxes, you have to code in your own data. Like you have to insert, you have to create tables and build all of it from scratch. And like at the level you all are at, like that's not something you need to be worried about. You just want to get good at querying the data and maybe doing some updates here and there. And so this has the data laid out for you in a way that where the data is clean, it actually relates to each other, and you can do joins and stuff. And so I think this is the best resource, the simplest resource that I've found to do these types of queries. Okay, I'm not seeing any additional questions on deletes or updates that haven't been answered, but let me know if I missed anything. Yeah, there's a question about nullifying columns. So yeah, sometimes you can put safeguards on columns where they aren't allowed to be null, which can, which you would want to do for like crucial data that is not allowed to be null and prevent them from accidentally being nullified. And so yeah, you can, there's certain safeguards you can do on the data itself. Non-nullable columns are good for that. Okay, let's go back to the slides. We're going to finish up here. All right. So we talked about modifying tables, and we did our examples. So I have a little bit of homework for you if you want to. Of course, it's completely optional, but this is a little challenge for you. It's a little beyond what we talked about, so see if you can figure it out. So there's a famous comic by the webcomic XKCD, and it's and no spoilers. If you know the answer, do not spoil it, okay? Warning you. Little Bobby tables, indeed. All right, so if you have trouble reading it, it's a little shaky on the writing. It says, "Hi, this is your son's school. We're having some computer trouble." The mom says, "Oh dear, did he break something?" And the voice on the phone says, "In a way, did you really name your son Robert, single quote, parenthesis, semicolon, drop table students, colon, dash dash?" "Oh yes, little Bobby Tables, we call him." The voice on the phone says, "Well, we've lost this year's student records. I hope you're happy." And the mom says, "And I hope you've learned to sanitize your database inputs." So the question is, why does the student name Robert, single quote, parenthesis, semicolon, drop table students, semicolon, dash dash, cause the student records to disappear? And what does it mean to sanitize database inputs? If you know the answer, don't share it now. But I want to give people the chance to think about it and maybe do some research on their own. But feel free to tag me on Twitter once you do have the answer, and share that with me there. So do your research, figure it out, and figure out what's actually happening here. So Dad learned some SQL. Yeah, I like that. I think that's the name Elon Musk is planning to name his next child. I wouldn't be surprised. Yep. All right. So that's your homework if you want to. It's optional, but see if you can figure it out. Okay. So here's some resources as promised. If you have the slide deck open, you should be able to click into these resources, as links. We've got Khan Academy. We've got Code Academy, SQL Course, SQL Zoo, W3 Schools. This is the link to the sandbox that we were working in this entire time. SQL Bolt, somebody mentioned before. SQL Bolt is another great resource as well. And so, yeah, feel free to, check out these resources. There's tons more out there. Like I say, SQL is a massively popular language, and so there's tons of resources out there to help you learn it. don't dive, if you're in 100 devs, don't dive too deep. Just get to the point where you're comfortable writing select statements, you understand what a relational database is and how tables can be linked together, and understand how to do joins. And I would say that's really all you need to worry about. No, Linda, I'm not. Yes, SQL Bolt. I think it's one of those I meant to include on here, and I just forgot. So SQL Bolt is a really great resource as well. Yeah, actually, it's one I've recommended to multiple people. So I apologize, I don't have it on this slide, but you can Google SQL Bolt, and that's a good resource also. Somebody asked earlier about. Let's see, wait, my mouse back. All right, somebody asked what my stream schedule is. I think I missed the. I missed the actual chat. I can't find it. I apologize. But somebody asked what my schedule is. You can see my schedule on my Twitch channel homepage. I stream twice a week currently. I stream on Wednesday evening Eastern time at 7 p.m. And then Sundays may vary slightly. Once 100 Devs class resumes, I will just be going live whenever office hours are over. That's when I'll be going live. So whether that's 3 p.m., 4 p.m., 5 p.m., I don't know. I'm going to go live after office hours once we start up class again. So just FYI, that's the schedule. You can find it on my Twitch channel on the schedule tab. Okay, that's about it. I appreciate everybody for sticking around today. I hope you had a good time. I think our next step is to find somebody to raid and to pass you folks off onto another deserving streamer. Yeah, I'm glad you all had some fun tonight. Yeah, definitely. That's the mess around in that sandbox and just try stuff out. Get comfortable with select statements. Get comfortable with joins. Get comfortable, doing basic queries, and you'll be set. You'll be ready for those types of questions to pop up in interviews. You'll be confident. You'll be able to whiteboard that stuff out, and you'll be just fine. Awesome possum. Okay. Let's find someone to raid. So I'm going to pull this tab over onto my other screen here so we don't get that double window effect. And we're going to raid somebody. So any suggestions, as always, any suggestions on someone to raid? So I always ask, leave it open to suggestions if you would like. I see CM Griffing is online, but if anybody has any suggestions on somebody else, I'm happy to hear it. CM Griffing is always fun. You're pretty much constantly doing dev work. Yeah, I think Nate. Yeah, I agree. CM Griffing is a good option pretty much all the time. Yeah, let's go ahead and do CM Griffing. I'll pass you off to them, and I will talk to you all again on Wednesday. Looking forward to seeing you again soon. All right, for my American friends, have a great Independence Day weekend, and look forward to chatting with you again. Talk to you soon. Raid is starting now, and should be ready here in just a minute. All right. See you later.